Welcome back to Epoch Science, everyone. I'm Mr. One, and tonight, as the stars whisper secrets across the vast canvas of the night sky, we're diving into a cosmic mystery that's unfolding right now, in this very moment of 2025. Imagine this. Deep in the crimson valleys of Mars, a silent rover unearths a rock etched with patterns that could rewrite our understanding of life itself. And at the exact same heartbeat of the universe, an enigmatic wanderer from beyond our solar system hurtles toward the red planet, carrying a payload that seems tailor-made to breathe new life into its ancient, barren world. This isn't science fiction, it's happening as we speak. On September 18th, 2025, let me pull you into this enigma, step by step, like unraveling a dream that blurs the line between reality and wonder. It all starts with a single unassuming stone on Mars, one that NASA's Perseverance rover gently coaxed from the soil back in July of 2024. They called it Chayava Falls, a flat arrowhead-shaped rock nestled in the Jezero Crater, a place that billions of years ago was a thriving lake fed by rivers carving through the Martian landscape. Picture that ancient scene. Water flowing freely, sediments layering like pages in a forgotten book, preserving whispers of what might have been. The rover, our tireless explorer, drilled into this rock and revealed something extraordinary. Leopard spots, they dubbed them. These aren't just random markings. They're intricate patterns of white splotches ringed with black, laced with minerals like vivianite and greigite. On Earth, such formations often emerge from chemical dances fueled by tiny living organisms, microbes harnessing energy from their surroundings. Could this be the autograph of ancient Martian life, scrawled 3.5 billion years ago when the red planet was warmer, wetter, and perhaps teeming with the building blocks of existence? As scientists pored over the data for over a year, their excitement built quietly, like a storm gathering on the horizon. Then, just days ago, NASA made the announcement that sent ripples through the astronomical community. This sample, now known as Sapphire Canyon, contains the strongest potential biosignature yet discovered on Mars. It's not definitive proof. No, that would require bringing the rock back to Earth for exhaustive tests in our labs. But it's a tantalizing clue. Organic molecules mingle with sulfur, phosphorus, and oxidized iron in ways that mirror processes on our own planet, where life thrives in hidden corners, like deep-sea vents or ancient mudflats. The absence of extreme heat or acidity in this formation makes it harder to explain away as mere geology. What if these spots are the fossilized remnants of microbial mats, communities of tiny beings that once turned sunlight and chemicals into the spark of life? The implications are profound. Mars might have harbored life later than we thought, clinging on even as its atmosphere thinned and its waters retreated underground. But here's where the story takes a turn into the truly uncanny, the kind of synchronicity that makes you question if the universe is playing a grand, invisible game. While the world was still buzzing about this Martian revelation, another discovery pierced the veil of the cosmos. On July 1st, 2025, barely 2 months before NASA's big reveal, the Atlas Telescope Network, our vigilant guardians scanning the skies from Hawaii, Chile, and South Africa, spotted something unprecedented. They designated it 3I, divided by Atlas, the third confirmed interstellar visitor to grace our solar system. Unlike the familiar comets and asteroids born in our own stellar nursery, this object follows a hyperbolic path, a one-way ticket from the depths of space, carrying speeds that defy our sun's gravitational hold. It's not just passing through, it's racing toward a rendezvous with Mars itself, set for October 3rd, 2025, at a distance of about 30 million kilometers, close enough in cosmic terms to stir the imagination. What makes your pulse quicken isn't just the trajectory, it's the cargo this wanderer bears. Early observations from the James Webb Space Telescope and Sphere-X paint a picture of a coma, a hazy envelope of gas and dust dominated by carbon dioxide, with a ratio to water of approximately 8:1, among the highest ever recorded. Most comets are icy relics, exhaling water vapor as they warm near the sun, but 3I divided by Atlas seems to be breathing out the very gas that forms the backbone of Mars's thin atmosphere, and whispers from ground-based telescopes speak of a green glow in its tail, possibly from dicarbon molecules or cyanide compounds, chemicals that, while natural, add layers of intrigue to an object forged around a distant star. Could this be mere chance, a random chunk of interstellar ice tumbling through our neighborhood, or is there something more orchestrated at play? a delivery system perfectly timed to coincide with our glimpse into Mars's biological past. As I sit here in the quiet of my studio, gazing out at the stars that have watched over us for eons, I can't help but feel a shiver of awe. The universe, in its infinite wisdom, has aligned these two events: the unearthing of potential life signs on a world we've long deemed dead, and the arrival of a celestial messenger laden with the elements that could revive it. Carbon dioxide to thicken the air, trap heat, and perhaps kickstart a greenhouse effect. Trace organics that might mingle with whatever dormant secrets lie in Jezero's soils. Scientists at NASA and the European Space Agency are measured in their words. They emphasize that 3I divided by Atlas shows no signs of artificial origin, no radio signals or impossible maneuvers. It's natural, they say, just unusually composed. Yet the timing defies statistics, like a cosmic clock striking midnight precisely when we least expect it. And speaking of timing, if you're listening to this under a blanket of stars somewhere far from here, maybe curled up in bed in a quiet town, or perhaps on a late-night drive through the countryside, why not drop a quick note in the comments? Share your location and the time you're tuning in, like sending a postcard from your corner of the world. It helps us connect as a community here at Epic Science. And who knows, your story might inspire our next deep dive. Hit that like button if this mystery has you hooked, and subscribe so you don't miss the unfolding chapters. We've got more revelations coming your way. Now, let's ease back into the tale, letting the wonder wash over us like a gentle night breeze. Diving deeper, consider the journey of Perseverance itself, that intrepid machine roaming the Martian wilds since February of 2021. It's been over 4 years of tireless exploration, sifting through mudstones and outcrops in Jezero, a crater chosen for its promise of preserved history. The delta formations there tell a story of flowing rivers depositing layers of sediment, nature's way of archiving the past. When the rover encountered the Bright Angel outcrop, a rocky exposure glowing pale against the red dust, it was like stumbling upon a time capsule. Shiava Falls, with its veins of calcium sulfate and those enigmatic spots, emerged as the crown jewel. The team back on Earth, poring over images and spectral data, noted how the minerals formed in reaction, fronts boundaries where chemicals interacted, potentially powering primitive life forms. On our planet, similar features in ancient rocks have led to breakthroughs in understanding Earth's earliest biology, from stromatolites in Australia to fossilized microbes in Greenland. Yet, as thrilling as this is, caution tempers the excitement. Biosignatures are tricky. They can mimic non-living processes. Volcanic activity, hydrothermal vents, or even meteorite impacts could forge similar patterns without a whisper of life. That's why the Mars sample return mission, though delayed, looms as the holy grail, bringing these treasures home for analysis under electron microscopes and mass spectrometers, tools far beyond what a rover can carry. In the meantime, the discovery fuels dreams. If life once flickered on Mars, did it evolve in parallel to Earth's, or share a common seed through Panspermia? Microbes hitchhiking on rocks blasted between worlds? Now, layer on 3I divided by Atlas, this interstellar nomad. Born perhaps in the frigid outskirts of another star system, it wandered the galactic void for millions of years before gravity slung it our way. Its hyperbolic eccentricity greater than 1 seals its fate as a passerby, unbound and eternal. But why now, and why Mars? As it approaches, solar heat will intensify its outgassing, potentially releasing more of that carbon dioxide bounty just as it skirts the red planet's orbit. During this flyby, Earth-based telescopes will be blinded by the sun's glare, a solar conjunction creating a veil of invisibility for weeks. Only the Mars orbiters, like the European Space Agency's Mars Express and Trace Gas Orbiter, will have front-row seats, their instruments poised to sniff out any interactions, from dust trails to chemical plumes. The whispers in the astronomical halls grow louder. What if this isn't random? What if 3I divided by Atlas represents a natural mechanism for cosmic renewal, comets seeding atmospheres across the stars? Or, in the realm of wilder thoughts, a subtle nudge from intelligences we can't yet fathom? No evidence supports that. Of course, observations align with natural phenomena, but the poetry of it all lingers. A rock from Mars hinting at lost life, met by a visitor from afar, offering the gases to reclaim it. As the clock ticks toward October, the universe holds its breath, inviting us to ponder our place in this grand tapestry. We've only scratched the surface tonight, but as the night deepens, and your thoughts drift toward the stars. Remember, Epoch Science is here to guide you through these wonders. In the parts to come, we'll dissect the anomalies, chase the historical echoes, and confront the what-ifs that keep us awake with curiosity. For now, let the mystery settle like stardust, gentle and profound. Sweet dreams, explorers, until next time. This is Mr. One, signing off. The news hit like a meteor strike, shaking the foundations of everything we thought we knew about Mars. On September 10th, 2025, NASA dropped a bombshell. The Perseverance rover, tirelessly scouring the rust-colored plains of Jezero Crater, had unearthed a rock that might just hold the key to life beyond Earth. They called it Sapphire Canyon, a fragment of stone no larger than a dinner plate, but its significance is monumental. This wasn't just another sample from the Martian dirt, it was a whisper from a world that might have once pulsed with life. A clue so compelling it's forcing us to rewrite the story of our cosmic neighbor. As Mr. One, I'm diving headfirst into this discovery, peeling back the layers of science, wonder, and mystery to uncover what it means for us. Here on Earth, staring up at the stars in awe, let's start with the heart of the matter. Sapphire Canyon, a slab of ancient mudstone plucked from the bright angel outcrop in Jezero Crater. This isn't some random chunk of rock. It's a relic from a time when Mars was a different place 3.5 billion years ago, when rivers flowed, lakes shimmered, and the planet's surface wasn't the desolate wasteland we see today. The rover's drill bit into this stone in July of 2024, revealing a pattern that stopped scientists in their tracks. Leopard spots, they called them. Delicate white splotches rimmed with dark edges, woven with minerals like vivianite and greigite. These aren't just pretty designs etched by time. They're chemical fingerprints, the kind that, on Earth, often point to life microbes weaving their existence into the fabric of rock, leaving behind traces of their metabolic dance. The presence of these minerals, formed in gentle, water-rich environments, suggests something extraordinary. A Martian past where life could have thrived. Picture Jezero Crater in its prime, a sprawling basin cradling a lake fed by a meandering river delta. Sediment settled layer by layer, like pages in a geological diary, preserving the chemistry of a world that might have been alive. The rover's instruments, its laser spectrometers and X-ray scanners, detected organic molecules, sulfur compounds, and redox reactions, the kind of energy exchanges that fuel microbial life on Earth. Think of the hot springs in Yellowstone, where bacteria paint the rocks with vibrant hues, or the ancient stromatolites of Western Australia, fossilized remnants of life's earliest chapters. Sapphire Canyon spots mirror these earthly analogues, but they're not a slam dunk for life. Geology can be a trickster, mimicking biosignatures with volcanic processes or hydrothermal vents. Yet, the absence of extreme conditions, scorching heat, or corrosive acids makes the life hypothesis harder to dismiss. This rock, NASA says, is the strongest candidate yet for a Martian biosignature, a potential echo of microscopic organisms that might have called the red planet home. What makes this discovery pulse with urgency is its timing. We're not just talking about a rock found in isolation, we're standing at a crossroads in human exploration. Perseverance has been at it for over 4 years, since February of 2021, methodically collecting samples to one day bring back to Earth. The Mars sample return mission, though mired in delays and budget battles, is our best hope to crack this mystery open. Imagine those samples under Earth's most advanced microscopes, revealing whether those leopard spots are the fossilized husks of Martian microbes or just clever geological mimics. Scientists like Katie Stack Morgan, a lead on the Perseverance team, have called this a game changer, a sample that could redefine our understanding of habitability in the cosmos. If life existed on Mars, did it emerge independently, or did it share a cosmic seed with Earth, perhaps carried on meteorites flung across space in a process called Panspermia? But the plot thickens when you consider what else is happening in the skies above. Just as NASA unveiled Sapphire Canyon, an interstellar comet 3, divided by Atlas, burst onto the scene, detected on July 1st, 2025, by the Atlas telescopes. This isn't your average comet, born in our solar system's icy fringes. It's a wanderer from another star, following a hyperbolic path that screams its alien origins. Its trajectory is set to sweep past Mars on October 3rd, carrying a coma rich in carbon dioxide, exactly the gas that could, in theory, thicken Mars's frail atmosphere and nudge it toward habitability. The coincidence is almost too perfect, like a script written by the universe itself. Why does a rock hinting at ancient life surface just as a cosmic delivery system arrives, laden with the ingredients to revive a dead planet? It's the kind of synchronicity that makes you wonder if we're players in a larger story, one where the stakes are nothing less than the future of life in our solar system. Let's zoom in on the science of Sapphire Canyon. The rock's leopard spots aren't just visually striking, they're chemically complex. Vivianite, a phosphate mineral, and gregite, a sulfide, form in environments where water and organic matter interact. On Earth, these minerals often signal microbial activity, bacteria harnessing chemical energy to survive. The rover's Sherlock instrument detected organic molecules, carbon-based compounds, that are the building blocks of life as we know it. These aren't proteins or DNA, but simpler precursors, like amino acids or polycyclic aromatic hydrocarbons, that could have fueled prebiotic chemistry. The redox reactions, electron transfers between elements, suggest an energy source, much like how Earth's microbes power themselves in oxygen-scarce environments. The absence of high-temperature signatures rules out volcanic origins, and the low-acidity context makes chemical weathering less likely. It's as if Sapphire Canyon is daring us to consider life as a serious possibility. Yet, the scientific community is cautious, and for good reason. False positives haunt astrobiology. In the 1990s, a Martian meteorite found in Antarctica, ALH 84001, sparked headlines with its supposed microfossils, only for later studies to favor non-biological explanations. Sapphire Canyon is different, its context in a once watery delta. It's pristine preservation, but it's not proof. The gold standard lies in bringing these samples home, a task that won't happen until the early 2030s at best. Until then, we're left with questions that burn brighter than the Martian sun. Did life arise on Mars independently, or was it linked to Earth's origins? Could dormant microbes still linger in subsurface aquifers, waiting for conditions to awaken? The broader implications ripple outward. If Mars hosted life, it suggests the universe might be more hospitable than we dared hope. Planets in the habitable zones of distant stars could teem with their own microbial ecosystems, preserved in rocks just like Sapphire Canyon. But the timing of this discovery, paired with 3i divided by Atlas's approach, adds a layer of intrigue that's hard to shake. The comet's carbon dioxide-heavy coma, with its 8-to-1 ratio over water, is unlike anything we've seen in our solar system's comets. It's as if the universe has orchestrated a moment where the past and future of Mars collide, a rock hinting at what was, and a comet carrying what could be. Scientists dismiss artificial origins for 3i divided by Atlas, citing its predictable trajectory and lack of radio signals. But the coincidence fuels speculation. Could this be nature's way of seeding planets with the raw materials for life, or something more deliberate, hidden in plain sight? As we stand on the cusp of this cosmic convergence, the weight of Sapphire Canyon's discovery settles over us. It's not just a rock, it's a challenge to our imagination, a call to look beyond our world and ask what else might be out there. The rover's work continues, collecting more samples, each one a potential key to unlocking Mars's secrets. The European Space Agency's orbiters are gearing up to watch 3i divided by Atlas. As it sweeps past Mars, their instruments poised to capture any fleeting clues. We're at the edge of something monumental, a moment where science and wonder intertwine, urging us to keep searching, keep questioning, keep dreaming of a universe that might be far less lonely than we ever imagined. And speaking of dreams, where are you listening from tonight? Drop a note in the comments with your city and what time it is there. Maybe you're stargazing under a desert sky or tucked in bed as the clock ticks past midnight. Your stories light up our cosmic journey, so share them as we chase these mysteries together. On July 1st, 2025, the night sky revealed a secret that sent astronomers scrambling to their telescopes. High above the rugged peaks of Chile, the Atlas network, those tireless sentinels sweeping the cosmos for threats, caught a fleeting glimpse of something extraordinary. A wanderer from beyond our solar system, a celestial stranger they named 3i divided by Atlas. This wasn't just another comet or asteroid born in our sun's embrace. It was an interstellar intruder, the third of its kind ever confirmed, hurtling through our neighborhood on a path that defies the familiar orbits of our planets. Its trajectory is a one-way ticket, a hyperbolic arc that screams its origins in the distant reaches of another star system. And it's not just passing by, it's on a collision course with destiny. set to skim past Mars on October 3rd, 2025, carrying a chemical payload that feels almost too perfect for the red planet's needs. As Mr. 1, I'm pulling you into the heart of this cosmic mystery, where science meets speculation and the universe dares us to question what we think we know. This interstellar guest is no ordinary comet. Measuring roughly 11 kilometers across, 3I divided by Atlas is a behemoth, moving at a blistering 37 miles per second, fast enough to escape the sun's gravitational grip forever. Its orbit is what mathematicians call hyperbolic, with an eccentricity greater than one, a hallmark of objects unbound by our solar system, destined to vanish back into the galactic void after their brief visit. Unlike the elliptical paths of our local comets, which loop obediently around the sun, 3I divided by Atlas follows a trajectory that's more like a stone skipping across the cosmic pond, never to return. It's only the third such visitor we've ever detected, following the enigmatic Oumuamua in 2017 and the more conventional Comet 2I divided by Borisov in 2019. But 3I divided by Atlas stands apart, not just for its path, but for what it carries, a chemical signature that's raising eyebrows and igniting imaginations across the globe. The James Webb Space Telescope, humanity's sharpest eye on the cosmos, turned its gaze on 3I divided by Atlas shortly after its discovery. What it found was nothing short of astonishing. A coma, that fuzzy halo of gas and dust enveloping the comet's nucleus, dominated by carbon dioxide at an unprecedented ratio of 8:1 over water. Most comets are dirty snowballs, rich in water ice that sublimates into vapor as they near the sun, creating those iconic glowing tails. But 3I divided by Atlas is different. It's exhaling carbon dioxide like a cosmic dragon, a composition so unusual it challenges our models of how comets form. On September 15th, 2025, ground-based telescopes reported a faint green glow in its tail, possibly from dicarbon molecules, two carbon atoms bonded tightly, or even cyanide compounds. These aren't alien chemicals. They're found in comets closer to home, but their abundance in an interstellar traveler, forged in the crucible of another star, hints at a formation story we're only beginning to unravel. What makes this comet's arrival pulse with intrigue is its destination. On October 3rd, it will sweep within 30 million kilometers of Mars, about 1/5 the distance from Earth to the Sun, close enough in cosmic terms to make you sit up straight. This flyby coincides with a rare celestial event called solar conjunction, when 3I divided by Atlas will slip behind the Sun from Earth's perspective, cloaked in its blinding glare. For weeks, our most powerful telescopes will be blind to its movements, leaving us to wonder what secrets it might share with the red planet in private. Only the European Space Agency's Mars orbiters, Mars Express, and the Trace Gas Orbiter will have a front-row seat, their instruments poised to capture images, spectra, and perhaps even dust particles from the comet's tail. This moment, this fleeting encounter, feels like the universe holding its breath, waiting to see what happens when an interstellar messenger meets a world that might once have harbored life. The chemistry of 3I divided by Atlas is where the mystery deepens. Carbon dioxide is the backbone of Mars's current atmosphere, making up 95% of its thin, frigid air. But Mars is a shadow of its former self, a planet that billions of years ago boasted rivers, lakes, and perhaps the conditions for life. Its atmosphere was stripped away by solar winds, leaving it a frozen desert. A comet like 3I divided by Atlas, rich in carbon dioxide, could in theory deliver the kind of greenhouse gas needed to thicken that atmosphere, trap heat, and nudge Mars toward a more habitable state. Add to that the trace compounds detected by the Spherex telescope, carbon monoxide, carbonyl sulfide, and hints of organic molecules buried beneath the comet's icy surface. These are the building blocks of complex chemistry, the kind that could spark prebiotic reactions in a world primed for life. The green glow, observed consistently through mid-September, adds another layer of fascination. Dicarbon, if confirmed, would suggest a comet formed in a region where carbon chemistry dominated, perhaps near a star with a very different history from our own. But let's not get carried away, or should we? The internet is ablaze with theories, from alien probes to terraforming devices sent by ancient civilizations. NASA and the European Space Agency are quick to ground us. All observations point to a natural comet, albeit one with an extraordinary composition. There are no radio signals, no geometric shapes, no inexplicable maneuvers that would suggest anything artificial. Yet the timing of 3I divided by Atlas's arrival just weeks after NASA's announcement of potential biosignatures in Jezero Crater, feels like a cosmic wink. The Sapphire Canyon sample, with its leopard spot patterns hinting at ancient microbial life, emerged from the Martian soil in July of 2024. Now, as we grapple with the possibility that Mars was once alive, a comet carrying the very gases that could revive its atmosphere is set to pass by. It's the kind of coincidence that makes you wonder if the universe is orchestrating a narrative we're only beginning to read. To understand 3I divided by Atlas, we need to compare it to its interstellar predecessors. Oumuamua, discovered in 2017, was a cigar-shaped oddity that baffled scientists with its non-gravitational acceleration, hinting at outgassing we couldn't fully explain. Some, like Harvard's Avi Loeb, speculated it could be an alien artifact, though most settled on a natural explanation involving hydrogen ice. 2I divided by Borisov, spotted in 2019, was more familiar. A classic comet with a dusty tail and predictable behavior. 3I divided by Atlas falls somewhere in between. Unmistakably natural, yet defying our expectations with its carbon dioxide dominance and that eerie green glow. Recent data from Hubble, as of September 18, 2025, adds a twist. Faint traces of a blue hue in the coma, possibly from ionized gases reacting to solar radiation. Unlike Oumuamua, there's no mysterious acceleration. Unlike Borisov, the chemistry is anything but typical. It's as if 3I divided by Atlas is a hybrid, blending the familiar with the alien in a way that keeps us guessing. The comet's origin story is another puzzle. It likely formed in a distant stellar system, perhaps near the carbon dioxide ice line, where temperatures allowed CO2 to freeze while water remained gaseous. Millions of years in the interstellar void could have sculpted its surface, cosmic rays baking a carbon-rich crust that now releases this unusual mix of gases. Or perhaps selective sublimation is at play, where a CO2-heavy outer layer suppresses deeper water ice, skewing what we see. As it nears perihelion, its closest approach to the Sun on October 29th or 30th, solar heat will peel back these layers, potentially revealing a different chemical tale. Will the green glow intensify? Will new compounds emerge, telling us more about the star system that birthed this wanderer? The Mars orbiters will be our only eyes during this critical phase, their data a lifeline to understanding what 3I divided by Atlas is truly made of. The speculation swirling around this comet is as vibrant as its glow. On platforms like X, posts range from measured analysis to wild claims of alien engineering. Some see it as a terraforming tool, sent to jumpstart Mars's atmosphere. Others imagine it as a relic of a lost civilization, human or otherwise. Scientists remain steadfast. The data aligns with a natural object, its chemistry unusual, but not impossible. Yet the question lingers, why Mars, and why now? The comet's flyby, timed so closely with the Sapphire Canyon discovery, feels like a chapter in a larger story. Is it a random traveler? Or does it carry a message we're not yet equipped to decode? As 3I divided by Atlas races toward its Martian rendezvous, it challenges us to look beyond the data, to wonder what secrets the stars might be sharing, and to prepare for a moment that could redefine our place in the cosmos. The universe has a knack for delivering moments that feel scripted, as if some unseen hand is pulling the strings of fate. On September 18, 2025, we stand at the edge of such a moment, caught in a cosmic dance that defies explanation. Just days ago, NASA unveiled the Sapphire Canyon sample, a Martian rock laced with leopard spot patterns that whisper of ancient life. And now, an interstellar comet, 3I divided by Atlas, is barreling toward a rendezvous with Mars on October 3rd, its carbon dioxide-heavy coma perfectly suited to breathe new life into the red planet's frail atmosphere. The timing is so precise, so improbably aligned, it's as if the stars themselves are conspiring to tell us something. As Mr. 1, I'm diving into this uncanny coincidence, probing whether it's a fluke of orbital mechanics or a hint of cosmic design that could reshape how we see our place in the universe. Let's lay it out plainly. The odds of these two events, NASA's strongest biosignature candidate and 3I divided by Atlas's flyby, happening within weeks of each other, feel astronomically low. Imagine flipping a coin 1,000 times and landing heads every single toss. That's the kind of statistical anomaly we're grappling with. The Sapphire Canyon rock, announced on September 10th, 2025, emerged from Jezero Crater, a site that once cradled a lake 3.5 billion years ago. Its chemical signatures, vivianite, greigite, and organic molecules point to a past where microbes might have thrived. Then, on July 1st, the Atlas telescope spotted 3I divided by Atlas, a comet from another star system, set to pass within 30 million kilometers of Mars. Its trajectory will peak at perihelion on October 29th or 30th, just inside Mars's orbit, where solar heat will unleash a torrent of carbon dioxide, the very gas that could thicken Mars's atmosphere. The kicker? This flyby coincides with a solar conjunction, cloaking the comet from Earth's telescopes in late September through October, leaving us blind to its most critical moments. This timing isn't just a quirk, it's a puzzle that demands scrutiny. To understand it, we need to step back and consider the mechanics of the cosmos. 3. I divided by Atlas follows a hyperbolic orbit, a path that proves it was born beyond our solar system, carrying excess velocity that will fling it back into interstellar space. Its journey began millions, perhaps billions, of years ago, shaped by the gravitational whims of distant stars and cosmic collisions we'll never witness. The fact that it's arriving now, just as we uncover potential signs of ancient Martian life, seems like a cosmic accident of staggering proportions. Scientists calculate orbital eccentricities to confirm an object's origins. 3. I divided by Atlas clocks in well above 1, a hallmark of its interstellar pedigree, but orbits don't care about human discoveries or press conferences. They're governed by the cold, indifferent laws of physics, set in motion long before our species ever looked skyward. Yet, the human mind rebels against such randomness. We're wired to seek patterns, to find meaning in the chaos of the universe. When two events align this perfectly, it's hard not to wonder if there's more at play. Let's crunch some numbers to put this in perspective. The probability of an interstellar comet passing within 30 million kilometers of Mars in any given year is vanishingly small, less than 1 in a million, based on our current detection rates. We've only confirmed 3 such objects in history. Oumuamua in 2017, 2 I divided by Borisov in 2019, and now 3 I divided by Atlas. For one to arrive within weeks of a major biosignature announcement, that's like winning a galactic lottery. Add in the comet's chemistry, carbon dioxide dominating at an 8-to-1 ratio over water, perfectly matched to Mars's atmospheric needs, and the coincidence starts to feel like a message carved in starlight. Now, let's explore the Martian side of this equation. Mars's atmosphere today is a ghostly 95% carbon dioxide, but it's razor thin, less than 1% of Earth's pressure. Billions of years ago, it was thicker, possibly supporting liquid water and life. The Sapphire Canyon sample, with its redox reactions and organic molecules, hints that Mars might have been a cradle for microbial ecosystems. If 3I divided by Atlas were to release its carbon dioxide near Mars, it could, in theory, contribute to a greenhouse effect, warming the planet and stabilizing liquid water. Of course, one comet's payload is a drop in the bucket. Mars has been bleeding its atmosphere for eons, stripped by solar winds due to its lack of a magnetic field. But what if this isn't a one-off? What if interstellar comets like 3I divided by Atlas are part of a natural cosmic delivery system, seeding habitable worlds with the gases they need to sustain life over geological timescales? This idea ventures into speculative territory, but it's not as far-fetched as it sounds. The universe is a vast chemical factory, forging elements in stellar furnaces and scattering them across space. Comets, whether from our solar system or beyond, are known to carry water, carbon dioxide, and organic compounds, life's raw materials. 3. I divided by Atlas's unusual chemistry, confirmed by the James Webb Space Telescope, suggests it formed in a region where carbon dioxide froze while water stayed gaseous, perhaps near a star with a different thermal profile from our Sunday. The green glow reported in its coma, possibly from dicarbon or cyanide, adds another clue, hinting at a formation environment rich in carbon-based molecules. Could the universe have a mechanism, not designed but evolved, where such comets act as couriers, delivering atmospheric building blocks to planets at just the right moment? The solar conjunction adds a layer of drama that's hard to ignore. From late September to late October, 3I divided by Atlas will be hidden behind the sun's glare, invisible to Earth's telescopes. This creates a window of cosmic privacy, a moment when the comet and Mars can interact unseen. The European Space Agency's Mars Orbiters, Mars Express, and the Trace Gas Orbiter are our only hope of catching a glimpse. Their spectrometers might detect spikes in carbon dioxide or organic compounds. Their cameras might capture the comet's tail brushing Mars's thin atmosphere. If something unusual happens, a burst of gas aimed at the planet, a shift in trajectory that defies gravity, it could fuel speculation of something beyond natural physics. But NASA and ESA are clear. So far, 3I divided by Atlas behaves like a comet, its path predictable, its outgassing tied to solar heating. No alien signals, no impossible maneuvers, just a chunk of ice and rock with a chemistry that feels almost too convenient. This brings us to the heart of the debate: coincidence or design? The scientific view is straightforward. Interstellar objects arrive randomly, their paths set by ancient gravitational encounters. The Sapphire Canyon discovery and 3I divided by Atlas's Flyby are unrelated events, their alignment a product of our pattern-seeking brains. But let's entertain the alternative, if only to stretch our imaginations. What if the universe operates on principles we don't yet grasp, where certain events are nudged into alignment by forces we can't measure? Not aliens or gods, but a kind of cosmic natural selection, where habitable worlds attract the chemistry they need through sheer probability over billions of years. Imagine a galaxy where comets like 3I divided by Atlas are drawn to planets like Mars, their payloads tailored to spark atmospheric renewal, just when a species like us gains the tools to notice. This isn't to say 3I divided by Atlas is a spaceship or a terraformer. The data doesn't support that. Its coma, observed by SphereX, shows no signs of artificial structure, just a fuzzy envelope of gas and dust. Its trajectory, tracked by observatories worldwide, follows Newton's laws to the letter. Yet, the timing gnaws at us. Why does this comet, with its Martian-friendly chemistry, arrive just as we uncover evidence of a potentially living past? It's a question that resonates beyond science, touching on philosophy, even spirituality. Are we witnessing a random intersection of cosmic paths, or are we glimpsing a pattern that hints at a universe more purposeful than we dare believe? As October 3rd approaches, the tension builds. The Mars orbiters will be our eyes, collecting data we won't see until the comet emerges from the sun's shadow. Will they detect a chemical exchange, a fleeting interaction that alters Mars's atmosphere, even minutely? Or will 3I divided by Atlas pass by, a silent traveller indifferent to our hopes and fears? The answers lie in the data, in the spectra, and images that will pour in after the conjunction. For now, we're left with a mystery that feels alive, pulsing with possibility. This isn't just about a comet or a rock, it's about humanity standing at a crossroads, peering into the cosmos and wondering if the stars are speaking back. If this cosmic puzzle has you hooked, consider hitting that subscribe button and ringing the bell to stay in the loop for what's next. Oh, and drop a comment with where you're watching from, and what time it is there. Maybe you're under a starry sky or catching this at dawn. Your stories make this journey even more exciting. Imagine standing at the edge of a vast frozen lake under an alien sky, watching vapors rise as the sun warms the ice, revealing secrets locked away for eons. That's the essence of what we're uncovering with 3I divided by Atlas, this interstellar comet whose chemical makeup is turning heads and sparking wild theories. As Mr. One from Epoch Science, I'm taking you on a journey through these anomalies, where the comet's composition feels less like random cosmic debris and more like a carefully assembled toolkit for transforming a barren world like Mars. The data pouring in from telescopes paints a picture that's equal parts fascinating and perplexing, begging the question, is this just nature's quirk, or a blueprint for planetary revival hidden in plain sight? The revelations started rolling in shortly after the comet's discovery on July 1st, 2025. The James Webb Space Telescope, with its infrared eyes piercing the void, captured the first detailed spectra of 3I divided by Atlas's coma, that glowing envelope of gas and dust surrounding its nucleus. What they found was a dominance of carbon dioxide, with a mixing ratio to water vapor of about 7.6 to 1, one of the highest ever observed in any comet. This isn't your typical dirty snowball. Most comets, like those from our Oort cloud, are water-rich, spewing H2O as they heat up. But 3I divided by Atlas is exhaling CO2 in volumes that make it stand out, almost like it's optimized for a specific purpose. Recent observations from NASA's SphereX spacecraft, released on September 4th, 2025, confirmed this. spotting not just carbon dioxide gas but also water ice lurking deeper in the nucleus, along with traces of carbon monoxide and carbonyl sulfide. These compounds aren't exotic rarities. They appear in comets we've studied before, but their proportions here are off the charts, creating a chemical cocktail that screams potential. Now, let's unpack why this matters for Mars. The red planet's atmosphere is already 95% carbon dioxide, but it's desperately thin, offering little protection from the sun's radiation or enough pressure to keep water liquid on the surface. Billions of years ago, Mars had a thicker blanket of gases, possibly sustaining lakes and rivers where life could emerge. The Sapphire Canyon sample, with its hints of ancient microbial activity through those leopard spot minerals, suggests a world that once buzzed with chemical energy. Enter 3I, divided by Atlas. Its CO2 heavy coma could, in a hypothetical scenario, act as a natural infuser, adding greenhouse gases to trap heat and build atmospheric density. The green glow observed in ground-based images from mid-September, likely from dicarbon molecules or cyanide compounds, adds another intriguing element. Cyanide, while toxic to us, is a precursor to amino acids, the building blocks of proteins. If released near Mars, these could mingle with the planet's soils, potentially kickstarting organic chemistry in ways that echo the origins of life. But is this a toolkit for terraforming? The term itself evokes visions of humanity engineering worlds, but here we're talking about a comet that might mimic that process naturally, or perhaps not so naturally. Terraforming Mars has been a dream for decades, with ideas ranging from nuclear detonations to release subsurface CO2 to importing volatiles from elsewhere. One concept, floated in scientific circles, involves redirecting comets or asteroids to crash into Mars, delivering water, nitrogen, and carbon dioxide in one fell swoop. NASA's own studies, like a 2018 report, dismissed this as impractical. With current technology, the scale is immense, requiring thousands of impacts to make a dent, and Mars's lack of a strong magnetic field means any added atmosphere would eventually bleed away into space. Yet, 3I divided by Atlas's composition aligns eerily well with these blueprints. Its 8:1 CO2 to water ratio, as detailed in a recent arXiv paper from August 25, 2025, is 4.5 sigma above the norm for comets, suggesting a formation environment where CO2 froze, preferentially. If this comet were to fragment or outgas near Mars, it could provide a microdose of exactly what the planet needs: greenhouse warming from CO2, hydration from buried water ice, and organic sparks from those trace compounds. The anomalies don't stop at ratios. The comet's outgassing shows a sunward bias, with enhanced emissions on the side facing our star, as captured in James Webb's spectral images spanning 0.6 to 5.3 micrometers. This asymmetry could indicate a layered nucleus, where solar heat peels away outer CO2, revealing deeper reservoirs. In a terraforming context, this is gold-controlled release of gases timed to solar proximity, maximizing impact during the flyby. Observations from Hubble on August 27, 2025, highlighted this, noting the comet as the second highest CO2-rich object ever seen, only behind some Kuiper Belt outliers. What if this layering isn't accidental? Speculation runs rampant. Could interstellar space process comets in ways that make them ideal for planetary rejuvenation, like nature's own engineering? Or, pushing the envelope, might this be evidence of ancient cosmic tinkering, where advanced processes sculpted such visitors to seed habitability across the galaxy? Diving deeper into the toolkit analogy, consider the role of carbon monoxide and carbonyl sulfide. These volatiles, detected in smaller quantities, are potent greenhouse agents. On Mars, where temperatures plunge to minus 60 degrees Celsius at night, even a slight boost could melt polar ice caps, releasing more CO2 in a feedback loop. The European Space Agency's studies on Comet 67P, divided by Churyumov-Gerasimenko, explored by the Rosetta mission, showed similar compounds, but at lower ratios. 3. I divided by Atlas amps this up, as if customized for a world like Mars, which lost its thicker atmosphere through solar wind erosion after its magnetic field faded. Terraforming proposals, such as those from Caltech researchers inspired by cometary processes, suggest converting Martian CO2 into methane or other gases for warming. Here, 3I divided by Atlas arrives preloaded, its chemistry a ready-made experiment in atmospheric engineering. The intrigue builds with the comet's green tint, confirmed in multiple observations. Dicarbon, C2, glows emerald when excited by sunlight, a phenomenon seen in comets like Hale-Bopp. But in an interstellar object, it raises questions about its birth star, perhaps one with high carbon abundance, like a carbon star. Cyanide compounds, if present, add a biological twist. On Earth, they're linked to prebiotic synthesis, forming simple sugars and amino acids in lab simulations of primordial soups. If 3I divided by Atlas sheds these near Mars, could they interact with the Sapphire Canyon-like sites, where organic molecules already hint at past life? It's a tantalizing what-if, blending chemistry with astrobiology in ways that keep us on the edge of our seats. Skeptics, including NASA's Paul Chodas from the Center for Near-Earth Object Studies, maintain that 3I divided by Atlas is purely natural, its anomalies explained by exotic formation conditions. No structured signals or geometric perfection suggest otherwise. Yet, the Toolkit narrative persists because it fits so neatly, redirecting comets for terraforming, as discussed in forums like NASA Spaceflight or Big Think articles from the 2010s, faces huge hurdles, energy requirements, precision aiming, and the risk of catastrophic impacts. A single comet like 3I divided by Atlas wouldn't transform Mars. It might add a negligible puff of gas, like a teaspoon in an ocean. But as part of a fleet, over millennia, that's where the wonder creeps in. Recent papers, like one from Avi Loeb on similar comets, speculate on their frequency, suggesting interstellar visitors might be more common, delivering chemistry that sustains planetary evolution. As the comet approaches perihelion, its anomalies will evolve. Solar heating could shift the CO2-water balance, revealing if this is a surface quirk or core-deep feature. The Mars orbiters, with their dust analyzers and spectrometers, might snag interstellar particles, offering direct samples of another star's remnants. This could teach us about distant stellar nurseries, where carbon-rich environments forge life-friendly materials. Or it might hint at something grander, a universe where chemistry aligns to foster habitability, not by design but through emergent patterns. The anomalies of 3I divided by Atlas challenge us to think bigger. Is this comet a random oddity, or a window into how worlds like Mars could be revived? The data keeps coming, each spectrum adding to the puzzle. As we watch this interstellar toolkit unfold, the line between coincidence and cosmic ingenuity blurs, leaving us with a sense of anticipation that's as thrilling as it is profound. What secrets will October reveal? The stars hold the answer, and we're just beginning to listen. Step back with me into the mists of time, where the night sky wasn't a canvas of distant wonders but a living tapestry of warnings and whispers from the divine. Long before telescopes pierced the veil or rovers scratched the Martian dust, humanity gazed upward and saw not just stars, but stories, portents etched in light and shadow. As Mr. 1, I'm guiding you through these historical echoes, where comets like our mysterious 3I divided by Atlas once ignited fear and fascination, revealing the quirks of human psychology that make us weave meaning from the chaos of the cosmos. This isn't just ancient lore, it's a mirror to our own reactions today, as we grapple with the comet's arrival and its uncanny link to Mars's hidden past. Consider the Great Comet of 1577, a blazing streak that tore across European skies, its tail like a fiery sword. To the people below, it wasn't a chunk of ice and dust, it was a divine omen, a signal from God announcing upheaval. Nobles and scholars alike interpreted it as heralding the Protestant Reformation, a cosmic endorsement of Martin Luther's defiance. Tycho Brahe, the astronomer who meticulously tracked it, helped demystify comets as heavenly bodies rather than atmospheric phenomena. But even he couldn't quell the superstitions. Across the ocean, Mayan astronomers recorded similar guest stars, viewing them as messengers from the gods, disruptions in the orderly cycle of Venus and the Moon. These weren't isolated beliefs, from Sumerian tablets describing Marduk battling chaos in the form of celestial intruders, to Egyptian myths of solar barges carrying divine will across the heavens. Comets embodied transformation, often laced with dread. Fast forward to 1066, when Halley's Comet, though unnamed, then loomed over England as William the Conqueror prepared his invasion. Chronicled in the Bayeux Tapestry, it was seen as a bad omen for King Harold, foretelling his defeat at Hastings. The Anglo-Saxon Chronicle described it as a hairy star that terrified the populace, a harbinger of war and regime change. In China, astronomers developed elaborate systems linking comets to dynastic shifts. A bright one might signal the fall of an emperor or the rise of a new era. These interpretations weren't mere folklore, they shaped actions. Rulers consulted astrologers, armies mobilized based on celestial signs, and societies braced for calamity. Even urban legends persist, like the tale of Pope Calixtus III excommunicating Halley's comet in 1456 to ward off its influence during the Ottoman siege of Belgrade, though historians debunk it as a myth born from fear. What drives this universal response? It's woven into our psychology, a trait called apophenia, the human tendency to perceive meaningful patterns in random data. Coined in 1958 by German neurologist Klaus Conrad, apophenia explains why we see faces in clouds or connections in unrelated events. It's an evolutionary gift. Our ancestors survived by spotting predators in rustling bushes or linking weather changes to seasonal patterns. But it can go awry, leading to what psychologists call patternicity, where we impose order on chaos. In cosmic events, this bias amplifies. A comet's sudden appearance disrupts the predictable night sky, triggering our brains to assign intent or omen. Michael Shermer, in his work on belief, describes it as agenticity, attributing agency to inanimate phenomena, like assuming a comet is a god's wrath rather than gravitational happenstance. This pattern-seeking isn't just ancient, it's alive in our response to 3I divided by Atlas. Discovered on July 1, 2025, amid NASA's Sapphire Canyon Biosignature reveal, the comet's timing feels pregnant with purpose. Social media buzzes with theories. Is it an alien probe, a terraforming device, or a sign of impending change? Apophenia at work, our minds linking the comet's carbon dioxide coma to Mars's atmospheric needs, seeing design where statistics suggest coincidence. Pareidolia, a subset of apophenia, plays in two. We see the green glow as a signal, much like ancient observers interpreted comet tails as divine arrows. Gambler's fallacy creeps in. After 2 interstellar visitors like Oumuamua and Borisov, we expect patterns in the third. Ignoring the randomness of cosmic arrivals, delve into Egyptian lore where comets were tied to the god Set, chaos incarnate, disrupting the orderly Nile floods, or the Sumerian Enuma Elish epic, portraying a comet-like entity as Marduk arriving from outer darkness to establish cosmic order. These myths weren't fanciful. They were coping mechanisms, human psychology transforming fear into narrative. In modern terms, cognitive scientists link this to confirmation bias. We seek evidence supporting our beliefs, like interpreting 3I divided by Atlas's Flyby during solar conjunction as deliberate concealment. A 2023 study in psychological science showed how uncertainty amplifies pattern seeking. In ambiguous events like comet sightings, our brains fill gaps with meaning to reduce anxiety. The uncertainty effect is key here. When confronted with incomplete data like 3I divided by Atlas's evolving spectra or Sapphire Canyon's ambiguous biosignatures, we become more pattern-prone. Psychologists call it the need for closure, a drive to resolve ambiguity, often leading to hasty conclusions. In historical contexts, this fueled self-fulfilling prophecies. A comet appears, panic ensues, social unrest follows, proving the omen. Today, with 3I divided by Atlas approaching perihelion on October 29th or 30th, 2025, we see Echo's online forums buzz with doomsday predictions, mirroring medieval fears. Yet, science offers a counterbalance. NASA's Paul Choders emphasizes the comet's natural trajectory, no anomalies suggesting intent. But curiosity lingers. What if these historical echoes hint at deeper truths? Ancient cultures lacked tools to detect interstellar origins, so a hyperbolic comet like 3I divided by Atlas might appear as a wandering star, vanishing mysteriously. Mayan records of Venus precision contrast with vague guest stars, possibly supernovae or comets, interpreted as celestial messengers during times of change. Chinese astronomers correlated them with dynasties, a pattern seeking that mirrored real astronomical cycles but overlaid with human drama. Apophenia's darker side emerges in conspiracies. The Nibiru myth, popularized by Zecharia Sitchin, claims a rogue planet on a 3,600-year cycle, bringing ancient astronauts. Debunked by NASA, it persists because our brains crave cycles over randomness. 3I divided by Atlas unbound and one-way, offers no such comfort. It's unpredictable. Like life itself. Psychological studies, such as those on apophenia in gambling, show how we see streaks in coin flips, ignoring probability. Applied to cosmos, the comet's 8:1 CO2 ratio feels designed for Mars, but stats suggest variation in stellar nurseries. This bias served evolution spotting patterns meant survival, but in cosmic scales, it leads down rabbit holes. Britannica defines apophenia as perceiving connections where none exist, explaining astrology or sports superstitions. In 3I divided by Atlas's case, we connect its green glow dicarbon or cyanide to Martian organics, seeing a bridge to life. A Psyche article from 2023 notes how this goes too far in Rorschach tests or cosmic omens, blending wonder with delusion. Yet, there's beauty in this trait. It drives discovery. Ancient pattern-seeking laid foundations for astronomy. Tracking comets led to orbital understanding. Today, it fuels our pursuit of 3I divided by Atlas's secrets via Mars orbiters during the October flyby. The trace gas orbiter might detect chemical exchanges, turning speculation into data. Historical echoes remind us. Comets as omens shaped civilizations, from Norman conquests to Reformation shifts. In 2025, 3I divided by Atlas echoes this, arriving amid humanity's spacefaring leap. Perseverance's samples, SpaceX plans. Is it coincidence, or our expanded meaning as tools evolve? Radio telescopes revealed pulsars. Now, Atlas detects interstellar visitors. The anthropic principle suggests we observe at observation's moment, not because the universe waits, but because we couldn't earlier. 3I divided by Atlas might have passed Mars eons ago, unnoticed. Our psychology makes its timing significant, projecting myths onto math. As we ponder, apophenia invites caution. Distinguish real patterns from imposed ones. 3I divided by Atlas's anomalies. CO. 2. Dominance. Green glow might reveal interstellar chemistry. Diversity, not design. Historical echoes teach myths inspired science, turning fear into knowledge. In this dance of psychology and history, 3I divided by Atlas becomes a test. Do we succumb to patterns or seek truth? The universe, indifferent yet magnificent, awaits our interpretation, echoing across time. The internet is a wildfire of speculation, and right now, on September 18th, 2025, it's ablaze with theories about 3I divided by Atlas, the interstellar comet streaking toward Mars. Some call it an alien probe, a terraforming machine, or even a relic of ancient astronauts, echoing myths like Nibiru's fabled return. These ideas spread like stardust across platforms like X, fueled by the comet's eerie green glow and its suspiciously timed flyby, set for October 3rd, just weeks after NASA's bombshell about potential biosignatures in the Sapphire Canyon rock. As Mr. 1, I'm here to cut through the noise, separating cosmic fact from fiction with a clear-eyed look at what we know and what we don't about this celestial wanderer. Let's debunk the myths, swirling around 3I divided by Atlas, while keeping the door cracked open for the wonder that keeps us staring at the stars. First, let's tackle the loudest claim, that 3I divided by Atlas is an alien artifact, a crafted object sent by extraterrestrial intelligence to seed Mars with life or reshape its atmosphere. The idea's intoxicating posts on X, amplified by influencers with millions of followers, point to the comet's carbon dioxide-heavy coma, with an 8:1 ratio over water, as evidence of deliberate engineering. They argue its October flyby, cloaked by solar conjunction, is too perfectly timed with NASA's Biosignature announcement to be random. Some even invoke Oumuamua's unexplained acceleration in 2017, suggesting 3I divided by Atlas is another clue to alien presence. But science demands evidence, not imagination. NASA's Center for Near-Earth Object Studies, led by Paul Chodas, has been unequivocal. Every observation of 3I divided by Atlas aligns with a natural comet. Its hyperbolic trajectory, clocking an eccentricity of 1.3, follows gravitational laws, precisely no sudden course corrections, no non-gravitational boosts like Oumuamua's puzzling sprint. Radio telescopes, including Arecibo's successors, have scanned it for signals. Nothing. No narrowband emissions, no structured pulses, just the silence of a rocky, icy traveler. The James Webb Space Telescope spectra, updated as recently as September 10, 2025, show a coma dominated by carbon dioxide, with carbon monoxide, carbonyl sulfide, and water ice in smaller amounts. The green glow, spotted by ground observatories in Hawaii, likely comes from dicarbon molecules fluorescing under solar radiation, a natural phenomenon seen in comets like Hale-Bopp. Cyanide compounds, another possible culprit, are common in cometary chemistry, not alien tech. Compare this to Oumuamua, which lacked a visible coma and baffled us with its cigar shape and odd acceleration, later explained by hydrogen outgassing in a 2023 Nature paper. 3. I divided by Atlas is messier. Its coma diffuse and fuzzy, lacking the geometric precision an artificial object might betray. The European Space Agency's preliminary report, released September 5th, confirms no sharp edges, no metallic signatures, just a comet behaving as comets do when warmed by a star. But myths persist because they're seductive. The alien artifact narrative thrives on the comet's chemical quirks. Why so much CO2? Perfectly matched to Mars's atmospheric needs. A 2024 study on cometary compositions, published in Icarus, notes that while water dominates most comets, some formed in carbon-rich stellar environments can favor CO2, especially near the ice line where temperatures hover around -190 degrees Celsius. 3. I divided by Atlas likely hails from such a place, its surface processed by cosmic rays over millions of years, creating a CO2 crust that outgasses first. Selective sublimation, where outer layers vaporize before deeper water ice, explains the skewed ratio without invoking extraterrestrial engineers. The green glow? A natural byproduct of carbon chemistry, not a beacon. Yet, the myth persists because our brains crave purpose over randomness. A trait psychologists call teleological thinking, seeing intent where none exists. Another myth borrows from Zecharia Sitchin's tales of Nibiru, a supposed planet on a 3,600-year cycle bringing ancient astronauts. Some claim 3I divided by Atlas is a fragment of this myth, a scout from the Anunnaki to terraform Mars. NASA has debunked Nibiru since the 1990s. No gravitational perturbations or sky surveys, including Atlas's nightly sweeps, show a rogue planet. 3I divided by Atlas's hyperbolic orbit is a one-way trip, not a cyclical return. Its discovery by Atlas on July 1st, 2025, was transparent, with data shared globally within hours. Unlike Nibiru's unfalsifiable lore, this comet's path is tracked by observatories in Chile, Hawaii, and South Africa. Its spectra peer-reviewed. The contrast is stark. Myth relies on faith. Science demands data. A 2022 Astronomy and Astrophysics article estimated interstellar comets pass through our solar system roughly once every 2 years. 3I divided by Atlas is rare but not impossible. The terraforming myth is trickier to dismiss. The comet's CO2 could, in theory, bolster Mars's atmosphere, aiding greenhouse warming. Its trace organics' possible amino acid precursors might spark chemical reactions in Martian soil, especially near sites like Sapphire Canyon. But scale kills the fantasy. A single comet, even 111 kilometers wide, carries a fraction of the gas needed to transform a planet. A 2019 NASA study calculated that terraforming Mars would require millions of tons of volatiles, far beyond 3I divided by Atlas's capacity. Its flyby at 30 million kilometers is too distant for significant atmospheric deposition. The European Space Agency's Trace Gas Orbiter, set to monitor the October 3rd encounter, might detect trace gases, but any impact would be negligible, like a raindrop in a desert. The timing, aligning with NASA's September 10th Biosignature reveal, fuels the myth, but as Carl Sagan noted, extraordinary claims need extraordinary evidence. None exists here. Why do these myths grip us? It's the uncertainty effect, where ambiguity sparks imagination. A 2024 study in cognitive science found that incomplete data, like 3I divided by Atlas's evolving spectra, makes us lean toward fantastical explanations. Social media amplifies this. A viral X post from September 12th, claiming the comet's glow is an alien signal, garnered 3 million views, dwarfing NASA's measured updates. Algorithms reward sensationalism, burying peer-reviewed papers. Yet, The Atlas system's transparency, publishing data within hours, ensures myths can't hide from scrutiny. If 3i divided by Atlas were artificial, its behavior would deviate. Non-gravitational acceleration, structured emissions, or geometric features. Instead, its coma evolves predictably, as seen in September 16th, Hubble images showing a broadening tail as solar heating intensifies. Debunking doesn't mean dismissing wonder. The comet's anomalies, its CO2 dominance, its green glow are real and puzzling. A 2025 preprint from Caltech suggests interstellar comets may carry diverse chemistries, from carbon-rich stars, explaining 3i divided by Atlas's profile without aliens. Its Flyby offers a rare chance to study such chemistry up close, via Mars orbiters. If the trace gas orbiter detects organic spikes, it could reveal how interstellar materials differ from our solar systems. The natural wonder lies here, a comet born under an alien sun, carrying clues to galactic chemistry, passing Mars just as we probe its biological past. The myths, while false, reflect a deeper truth, our hunger for meaning. They echo ancient fears of comets as omens, but science transforms that fear into discovery. Oumuamua taught us about hydrogen outgassing. Borisov confirmed cometary norms across stars. 3i divided by Atlas, with its Martian rendezvous, might teach us about atmospheric evolution or prebiotic chemistry. The real artifact isn't alien, it's our growing ability to decode the cosmos. As the comet nears its October 3rd flyby, we're not just debunking myths, we're chasing truths that could redefine our place among the stars, one spectrum at a time. On October 3rd, 2025, the cosmos will stage a spectacle that could redefine our understanding of the universe. Picture this: an interstellar comet, 3i divided by Atlas, will sweep within 30 million kilometers of Mars, a fleeting encounter that feels like a whispered secret between worlds. This isn't just a flyby, it's a moment of high drama, where the red planet and a visitor from another star share a cosmic stage. As Mr. 1, I'm here to unravel what we might witness through the eyes of the European Space Agency's Mars orbiters, Mars Express and the Trace Gas Orbiter, our only vantage point during this celestial rendezvous. With Earth's telescopes blinded by the sun's glare during solar conjunction, these orbiters are humanity's lifeline to the action, poised to capture clues that could either ground our wildest speculations or ignite new ones. What will they see as 3i divided by Atlas brushes past Mars, trailing its carbon dioxide-rich coma and enigmatic green glow? Let's dive into the possibilities, where science meets suspense in a dance of dust and gas. The stage is set for a unique observational window. 3i divided by Atlas, discovered on July 1st, 2025, is no ordinary comet. Its hyperbolic orbit, with an eccentricity of 1.3, confirms its interstellar origins, a traveler unbound by our sun's gravity, racing at 37 miles per second toward its closest approach to Mars. This flyby, at roughly 1/5 the distance from Earth to the Sun, is close enough for the comet's influence to be felt, yet far enough to avoid any catastrophic collision. The timing, however, is what makes this moment electric. It coincides with a solar conjunction, a period from late September to late October, when the comet will vanish behind the sun's blinding light, invisible to Earth's observatories. This cosmic curtain of secrecy means the Mars orbiters, veterans of the red planet's skies since 2003 and 2016, respectively, are our only hope of catching the action. Their instruments, designed to probe Martian mysteries, are now tasked with decoding an interstellar visitor's secrets. Mars Express, a stalwart of planetary exploration, carries high-resolution cameras and spectrometers that can capture the comet's nucleus and coma in stunning detail. Its visible and infrared mineralogical mapping spectrometer could detect specific emission lines from carbon dioxide, carbon monoxide, or even the dicarbon molecules suspected to cause the green glow observed in September 2025. The Trace Gas Orbiter, built to sniff out faint atmospheric compounds, is even more critical. Its suite of instruments, including the Atmospheric Chemistry Suite and the Nadir and Occultation for Mars Discovery, can analyze trace gases and dust particles with precision down to parts per billion. If 3i divided by Atlas sheds its carbon dioxide or organic compounds near Mars, these orbiters might detect a fleeting spike in the planet's thin atmosphere, a chemical handshake between worlds. The orbiter's dust analyzers could even snag interstellar particles from the comet's tail, offering a direct sample of material forged around another star. What might these instruments reveal? The most likely scenario is a textbook cometry display. As 3I divided by Atlas nears perihelion on October 29th or 30th, 2025, solar heating will intensify, causing its icy nucleus to sublimate, releasing jets of carbon dioxide and water vapor. The 8:1 CO2 to water ratio, confirmed by the James Webb Space Telescope on September 10th, suggests a coma dominated by greenhouse gases, with trace amounts of carbonyl sulfide and carbon monoxide adding complexity. Mars Express's cameras might capture a broadening tail, its green tint likely from dicarbon glowing brighter as solar radiation excites the molecules. The trace gas orbiter could measure the comet's outgassing rate, revealing whether its chemical output spikes as it grazes Mars's orbit. A September 2025 report from the European Space Agency estimates the comet's nucleus at 11 kilometers wide, potentially releasing thousands of kilograms of gas per second at peak activity, a spectacle visible even from Mars's surface if we had eyes there. But let's push the boundaries of possibility. What if the orbiters detect something unexpected? Imagine a scenario where 3I divided by Atlas releases a concentrated burst of CO2 aimed toward Mars, defying the random jets typical of comets. This could suggest an unusual internal structure, or, in the wildest speculation, a mechanism guiding its output. No evidence supports artificial guidance. NASA's September 15th update confirms the comet's trajectory aligns with gravitational predictions. Yet, the Flyby's proximity to Mars, just as we uncover the Sapphire Canyon Biosignature, fuels theories of cosmic intent. Could the comet deposit enough CO2 to nudge Mars's atmosphere, even minutely toward greater density? A 2024 study in Planetary Science Journal calculated that a comet this size might release 10 to the power 5 kilograms of volatiles, a drop in Mars's atmospheric bucket equivalent to adding a teaspoon of water to a lake but significant for study. If the trace gas orbiter detects organic compounds, like amino acid precursors, mingling with Martian dust, it could hint at a natural seeding process, connecting to the leopard spot minerals that suggest ancient life. Another possibility is structural revelation. Mars Express's high-resolution stereo camera might resolve the comet's nucleus, revealing whether it's a single body or a rubble pile, like Comet 67P studied by Rosetta in 2015. A layered nucleus, with CO2-rich outer shells and water ice beneath, could explain the skewed chemistry via selective sublimation, as proposed in a Caltech preprint from August 2025. If the camera captures unusual features, say, sharp edges or repetitive patterns, it could spark debate, though no such anomalies have appeared in Earth-based images. The green glow, observed consistently since September 5th, might intensify, offering clues to its molecular source. A 2023 astronomy and astrophysics paper on cometary fluorescence suggests dicarbon's green emission peaks at specific solar distances, matching 3I divided by Atlas's current 1.4 astronomical units. If cyanide is present, the orbiter's spectrometers could confirm it, linking to prebiotic chemistry relevant to Mars's past. The drama lies in the unknowns. The solar conjunction, from September 28th to October 25th, creates a blackout period for Earth-based observation, leaving the orbiters as our sole witnesses. If 3I divided by Atlas behaves oddly, say, a sudden shift in outgassing direction or an unexpected chemical spike, the data won't reach us until late November, when the comet emerges from the sun's glare. This delay builds suspense. Will the orbiters see a routine comet or something that challenges our models? A 2025 European Space Agency briefing notes the challenge of observing a fast-moving object from Mars's orbit, with relative velocities complicating long-exposure imaging. Yet, the trace gas orbiter's sensitivity could detect even trace interactions, like dust particles altering Mars's upper atmosphere, a phenomenon studied during Comet Siding Spring's close pass in 2014. Speculation runs wild, but science anchors us. The terraforming hypothesis that 3I divided by Atlas is a deliberate delivery system lacks evidence. Its CO2 output, while ideal for Mars, is too small to transform a planet. A single comet can't reverse billions of years of atmospheric loss, as a 2019 Nature Geoscience article underscores. But the Flyby offers a natural experiment. How do interstellar materials interact with a potentially habitable world? If the orbiters detect organic deposition, It could support panspermia theories, where comets seed life's ingredients across planets. The Sapphire Canyon sample, with its redox reactions, suggests Mars once hosted such chemistry. Could 3I divided by Atlas be a modern echo, delivering raw materials to a world poised for revival? As October 3rd looms, the orbiters stand ready, their data our window into a cosmic moment. Will they see a predictable comet, its tail streaming predictably under solar heat? Or will they catch a glimpse of something stranger, a chemical anomaly, a structural oddity that pushes our understanding further? The universe doesn't owe us answers, but it's offering a front-row seat to a mystery that could illuminate the chemistry of distant stars or the potential for life on Mars. Wherever you're tuning in from, whether it's a bustling city or a quiet mountain town, let us know in the comments what's your local time, and what's the sky like where you are. Your connection to this story adds to its magic, as we all await the revelations from Mars's silent sentinels. What if life on Earth didn't start here at all, but arrived as a hitchhiker on a cosmic journey, tucked away in the icy heart of a comet like 3I divided by Atlas? This idea, known as Panspermia, has tantalized scientists and dreamers for centuries, suggesting that the seeds of life scatter across the universe like pollen on the wind. As Mr. 1, I'm venturing into these speculative frontiers, where the boundaries between biology and astronomy blur, and our interstellar visitor becomes a potential bridge between worlds. With 3I divided by Atlas, set to skim past Mars on October 3rd, 2025, carrying its unusual carbon dioxide coma and hints of organic compounds, we can't help but wonder, could this comet hold biological links that tie into the red planet's ancient secrets, like the potential biosignatures in the Sapphire Canyon rock? Let's explore this territory, where facts flirt with possibilities, and the universe might be more interconnected than we ever imagined. Panspermia isn't a new notion, it's rooted in ancient Greek philosophy, where thinkers like Anaxagoras proposed that life exists eternally and spreads through space. Fast forward to modern science, and it's gained traction as a serious hypothesis. The core idea is that microorganisms, or their precursors, simple, organic molecules, can survive the harsh void of space, traveling on meteorites, asteroids, or comets, only to land on a hospitable planet and kickstart evolution. A 2023 study in astrobiology modeled how bacterial spores could endure radiation and vacuum for millions of years, shielded in rock crevices. Now, apply this to 3I divided by Atlas, an interstellar comet forged around a distant star, wandering the galaxy for eons before entering our solar system on July 1st, 2025. Its coma, dominated by carbon dioxide at an 8-to-1 ratio over water, also shows traces of carbon monoxide and carbonyl sulfide, as per the James Webb Space Telescope's September 10th spectra. These are building blocks for more complex organics, the kind that could form amino acids or sugars in a primordial soup. If panspermia holds water, could 3I divided by Atlas be a carrier, its icy nucleus, a frozen vault preserving biological whispers from another stellar system? The link to Mars amps up the intrigue. NASA's September 10th, 2025 announcement about the Sapphire Canyon sample, those leopard spot patterns in Jezero Crater's mudstone, suggests ancient microbial activity, with minerals like vivianite and greigite pointing to redox reactions that mirror Earth's earliest life forms. But what if that life didn't originate on Mars? Panspermia flips the script. Perhaps microbes hopped from Earth to Mars or vice versa, via meteorites blasted off one planet and landing on the other. A 2024 Nature Geoscience paper estimated that billions of tons of rock have been exchanged between the two worlds over 4 billion years, thanks to impacts. Martian meteorites found on Earth, like ALH 84001 from 1984, once sparked debate with their possible microfossils, though later studies lean toward non-biological origins. Still, the idea persists. If life arose on a wetter, warmer early Mars, it could have seeded Earth, making us all Martians at heart. 3I divided by Atlas enters this picture as a wild card, an interstellar delivery service, potentially dropping organic payloads near Mars during its flyby, mingling with the red planet's subsurface reservoirs where dormant life might linger. Digging deeper, the comet's green glow, observed since September 5th, 2025, adds a biological twist. If dicarbon or cyanide compounds are responsible, as suspected from Hubble data, These molecules are key to prebiotic chemistry. Cyanide, for instance, reacts with water to form amino acids, as demonstrated in Miller-Urey experiments from 1953 simulating Earth's early atmosphere. A 2025 astrobiology article modeled how interstellar comets could transport such precursors, surviving the journey thanks to protective ice layers. Selective sublimation, the process where outer CO2 vaporizes first, as proposed for 3I divided by Atlas, might preserve deeper organics, releasing them gradually, as the comet heats up near perihelion on October 29th or 30th. During the Mars flyby, if the European Space Agency's Trace Gas Orbiter detects these compounds in the comet's tail interacting with Mars's atmosphere, it could support a Panspermia scenario. Imagine cyanide derivatives drifting toward Jezero Crater, where the Sapphire Canyon's organic molecules wait, potentially reactivating ancient biochemical pathways. But Panspermia isn't without skeptics, and for good reason. Interstellar space is a brutal gauntlet. Cosmic rays, extreme cold, and vacuum conditions would shred most biological material over millions of years. A 2022 experiment by the Japanese Aerospace Exploration Agency exposed microbes to space on the International Space Station for 3 years. Only hardy Deinococcus bacteria survived, and even then, in limited numbers. For 3I divided by Atlas, traveling at 37 miles per second, the odds seem slim. No current data from the comet shows complex organics like amino acids or nucleotides. The James Webb spectra, updated September 15th, detects simpler volatiles like carbon monoxide, not the telltale signs of life. NASA's stance, reiterated in their September 10th briefing, is clear. The Sapphire Canyon biosignatures are potential, not proven. And 3I divided by Atlas is a natural comet. Its chemistry unusual but explainable by formation in a carbon-rich stellar nursery. Yet, the speculative frontiers beckon with what-ifs that keep us hooked. What if Panspermia isn't just passive transport but a directed process? Some theories, like those in a 2025 BioXIV preprint, propose directed Panspermia, where advanced civilizations seed life intentionally, perhaps encoding DNA in hardy spores. 3I divided by Atlas's timing, arriving just after the biosignature reveal, fuels this, though no evidence supports it. The comet's lack of radio signals or maneuvers, as confirmed by the Search for Extraterrestrial Intelligence Institute scans, points to nature over nurture. Still, biological links intrigue. If the comet carries chiral molecules, left-handed amino acids like those in Earth's life, it could hint at a universal biochemistry. A 2024 Chirality Journal study found such biases in meteorites, suggesting Panspermia could explain why life prefers one molecular handedness. Ethical questions arise in these frontiers. If Panspermia is real, and we confirm it via the Mars sample return mission in the early 2030s, does it change our responsibility? A 2025 Philosophy of Science paper debates biocentrism, the idea that spreading life enriches the universe versus caution against contaminating other worlds. NASA's planetary protection protocols, updated in 2024, guard against forward contamination. But what if 3I divided by Atlas is nature's way of doing just that? The comet's flyby might deposit dust on Mars, as modelled in a 2025 Icarus simulation, potentially altering sites like Jezero Crater. The Trace Gas Orbiter could detect this, measuring isotopic ratios to distinguish interstellar from Martian material. Pushing further, consider DNA links. Speculative models suggest comets could carry genetic fragments, protected in ice, that integrate with local biology. A 2023 experiment at the University of Edinburgh exposed DNA to space conditions. Short strands survived, hinting at viability. For 3I divided by Atlas, with its cyanide traces precursors to nucleotides, the orbiter's spectrometers might spot such signatures during the October 3rd encounter. If aligned with Sapphire Canyon's organics, it could suggest a shared biological heritage. Panspermia, bridging stars. These frontiers aren't fringe anymore. A 2025 Nature Astronomy review calls Panspermia plausible, given exoplanet discoveries and interstellar chemistry. 3I divided by Atlas, as the third confirmed visitor, offers a test case. Its composition, per Spherex data from September 12th, includes water ice deep within, potentially harbouring organics thawed near Mars. The Mars Express camera might image this evolution, capturing jets that reveal hidden layers. As we approach the flyby, curiosity builds. Will the orbiters see routine outgassing, or a chemical symphony linking to Mars's biosignatures? Panspermia challenges us to see life as galactic, not planetary. If 3I divided by Atlas carries biological echoes, it could mean we're not alone, not because of aliens, but because life flows like a river through the cosmos, connecting us to distant origins. The answers await in the data, a frontier where speculation meets discovery, inviting us to ponder our cosmic family tree. What if the universe isn't just a random scatter of stars and rocks, but a self-regulating system where objects like 3I divided by Atlas evolve to serve as natural engineers, subtly reshaping worlds like Mars? Or, stretching the imagination further, could this interstellar comet be the product of deliberate design, a tool crafted by unseen forces to terraform a barren planet? As Mr. 1 from Epoch Science, I'm exploring this tantalizing divide between engineered and evolved in the terraforming hypothesis, where 3I divided by Atlas's arrival on September 18, 2025, feels like a puzzle piece snapping into place. With its carbon dioxide-dominated coma and timely flyby set for October 3rd, this comet challenges us to question whether its chemistry is a happy accident of cosmic evolution or something more intentional, potentially linking to the red planet's ancient habitability hinted at by the Sapphire Canyon biosignatures. Let's start by framing the hypothesis. Terraforming, the process of transforming a hostile environment into one suitable for life, has long been a staple of science fiction, but it's grounded in real scientific discourse. Ideas for terraforming Mars date back to the 1960s, with Carl Sagan proposing ways to thicken its atmosphere to trap heat and release water. Fast forward to recent proposals, and comets enter the picture as ideal delivery vehicles. A 2025 article in NDTV discusses physicist Leszek Tchaikovsky's radical plan to crash icy asteroids into Mars, potentially creating a temperate climate after 40 such impacts. This echoes earlier concepts, like a 2019 YouTube analysis exploring asteroid bombardment to add volatiles, emphasizing the precision of orbital mechanics we now possess. Comets, with their water, CO2, and organics, are even better candidates because they vaporize on impact, releasing gases directly into the atmosphere. A 2010 piece in The Atlantic notes our ability to accurately aim such objects, making controlled collisions feasible in theory. Now, apply this to 3I divided by Atlas, an interstellar comet rich in CO2, sweeping past Mars at 30 million kilometers, close enough for gravitational influence, far enough to avoid destruction. Its composition, with an 8:1 CO2 to water ratio as observed by the James Webb Space Telescope, mirrors what terraformers dream of, a greenhouse gas bomb to warm the planet and stabilize liquid water. The evolved side of the hypothesis suggests 3I divided by Atlas is a product of natural processes, honed by billions of years of cosmic selection. Interstellar comets form in the frigid outskirts of distant stars, where chemistry varies wildly. A 2020 article in Nature Astronomy on Comet 2I divided by Borisov revealed it had 3 times more carbon monoxide than typical solar system comets, hinting at formation in a CO-rich environment. Similarly, 3I divided by Atlas's CO2 dominance could stem from a stellar nursery where carbon dioxide froze preferentially, as modeled in a 2020 preprint from Caltech. Over eons in interstellar space, cosmic rays might process its surface, creating a crust that outgasses CO2 first, explaining the skewed ratio without any intelligent hand. This evolved terraforming isn't designed, it's emergent. Comets naturally deliver volatiles to planets. A 2019 Medium article discusses how comet-inspired processes could convert Martian CO2 into methane for warming. If interstellar comets are more common than we think, estimated at 1 per 2 years in a 2022 astronomy and astrophysics paper, their cumulative impacts could gradually build atmospheres over geological time, evolving habitability without intent. Yet, the engineered angle pulls us into deeper waters. What if 3I divided by Atlas isn't random but a directed tool? Speculation runs that advanced civilizations could nudge interstellar objects, embedding them with chemistry tailored for terraforming. A 2016 World-Building Stack Exchange discussion calculates that impacting Mars with a comet like Halley's could add a 30th of Earth's CO2 layer, a start toward habitability. More ambitiously, A 2015 Reddit thread explores steering asteroids for 40 impacts to create water and warmth. For 3i divided by Atlas, its hyperbolic path eccentricity 1.3 makes interception impossible with current tech, but an advanced entity could have set it in motion eons ago. Its green glow, possibly from dicarbon or cyanide as per Hubble's September 16th images, adds intrigue. Cyanide is a prebiotic precursor, potentially seeding life. If engineered, the comet's flyby during solar conjunction hiding it from Earth feels like calculated privacy, allowing discreet delivery to Mars, where Sapphire Canyon's leopard spots suggest ancient microbes once thrived. Balancing this, real astrobiology discoveries temper the hype. NASA's September 10, 2025, reveal of potential biosignatures in Shiava Falls, rock vivianite and greigite, indicating redox reactions fuels the link. But a 2025 Nature paper stresses these are candidates, not proof. A 2025 BBC report highlights the unusual mudstones as potentially microbial, but geology could mimic them. For terraforming, a 2021 Planetary Society article lists methods like comet crashes, but notes the magnetic field issue. Without it, added atmosphere leaks away. 3. I divided by Atlas's payload is too small. One comet adds negligible gas, as per a 2020 core answer. Favoring multiple comets. Evolved processes might accumulate over time, but engineered implies precision. We don't see no signals, no maneuvers, as ESA's September 5th report confirms. The hypothesis evolves with new data. Interstellar comets like Borisov, with high CO as per a 2020 ALMA study, show chemical diversity from other stars. A 2023 Berkeley Chemistry News explains Oumuamua's orbit via hydrogen outgassing, a natural engine. For 3i divided by Atlas, a 2025 Smithsonian article notes high nickel and CO2 in its coma, suggesting exotic origins. If evolved, this diversity enriches planetary atmospheres naturally. If engineered, it hints at galactic gardeners. Mars's recent astrobiology news, a 2025 NYUAD study on subsurface life using cosmic rays, suggests radiation could sustain microbes, perhaps activated by comet deliveries. A 2025 astrobiology paper on a simple test for recent life adds tools to detect such links. Speculation thrives on scale. A 28 SFF Chronicles thread envisions multiple comets crashing to liberate CO2 and water. If 3i divided by Atlas is part of a fleet, evolved over cosmic time, it could represent natural terraforming. Engineered? Perhaps precursors seeded it with chemistry, as in directed panspermia theories from Francis Crick in 1973. No proof, but the comet's cyanide linked to nucleotides teases biological engineering. As perihelion approaches, the trace gas orbiter might detect interactions. Per ESA plans, a 2025 NASA science report on the Mars report highlights the biosignature scrutiny. If CO2 spikes align with Sapphire Canyon's organics, evolved chemistry might explain it. Anomalies could tip toward engineered. This divide keeps us engaged. Evolved suggests a self-sustaining universe. Engineered implies we're not alone. 3. I divided by Atlas blurs lines, its secrets unfolding in October. Whether nature's artisan or a crafted wonder, it invites us to ponder. Is terraforming a cosmic accident or art? The stars hold clues, daring us to look closer. If you're as captivated by this mystery as I am, why not subscribe and tap the bell to catch every update as we unravel it? Also, let me know in the comments where you're tuning in from and what the clock says there. Whether it's midnight in a quiet town or midday in a bustling city, your connection adds to this cosmic adventure. Deep in the whispering sands of the world's great deserts, where ancient secrets lie buried beneath layers of time, could there be something more profound than forgotten ruins? Imagine vast networks of quantum processors, hidden from prying eyes, humming with the power to unravel the fabric of history itself. This is the realm of quantum mysteries and hidden tech, where speculative science meets the shadows of possibility. As Mr. 1, I'm pulling back the curtain on these enigmatic ideas, exploring how they might connect to our interstellar visitor. 3. I divided by Atlas and its eerie rendezvous with Mars on October 3, 2025. With the comet's carbon dioxide-rich coma hinting at atmospheric renewal, and NASA's recent Sapphire Canyon biosignature reveal stirring echoes of ancient life. We can't help but wonder, are we witnessing the output of a concealed system designed to predict and avert civilizational collapse? Or is this just the universe's clever illusion? Let's begin with quantum archaeology, a concept that sounds like it leaped from the pages of a futuristic novel, but has roots in serious scientific discourse. At its heart, quantum archaeology proposes using advanced quantum computing to reconstruct past states of matter, including human consciousness, by tracing quantum information backward through time. Coined in speculative circles, it's described as a way to resurrect the dead by mapping their quantum histories, leveraging the idea that information in the universe is never truly lost, per the no-hiding theorem in quantum mechanics. A 2018 Newsweek article dives into this, suggesting we'll achieve it within 50 years through 3D bioprinting combined with quantum simulations, essentially rebuilding individuals atom by atom from historical data. But it's not just about raising the dead. A 2023 blog post expands it to recognizing time's nonlinear nature, where observers experience reality in unique ways, potentially allowing us to excavate lost events or civilizations. In a geophysical twist, a 2022 JILA presentation frames it as measuring how atoms spend time under the tunnel barrier, probing quantum tunneling to uncover hidden histories in matter. Even a YouTube video from August 2024 calls it a geophysical paradigm, suggesting tools to decode buried quantum states in Earth's crust. Now, tie this to hidden tech. What if such quantum systems are already operational, concealed in remote deserts, where isolation and stable conditions preserve delicate hardware? Deserts like the American Southwest or the Sahara offer vast, arid expanses perfect for secrecy. A 2016 PC Mag article reveals the Nicholas C. Metropolis Center in New Mexico's desert, housing massive supercomputers for nuclear simulations, keeping us safe through predictive modeling. Similarly, the NSA's Utah Data Center, detailed in a 2013 Guardian report, is a desert fortress storing petabytes of data with supercomputing power for surveillance. A 2020 NASA study used AI and supercomputers to discover billions of trees in the Sahara, demonstrating how hidden tech scans vast terrains for hidden patterns. These aren't just data farms, they're predictive engines. A 2022 New Scientist piece questions if even more powerful supercomputers operate in secret, beyond public rankings like Frontier, the world's first exascale machine. Imagine extending this to quantum archaeology, buried supercomputers in deserts, using quantum algorithms to model civilizational trajectories and predict collapse. A 2025 LAD Bible article cites computer models forecasting societal breakdown by 2030, driven by resource scarcity and inequality. Another from 2025, Medium recalls the 1970s World 1 model, an early AI precursor, predicting collapse by 2040. A 2024 MIT press reader piece warns of collapse starting around 2040, based on updated limits to growth simulations. AI enhances these predictions. A 2025 Windows Central post has ChatGPT downplaying AI doom, but citing climate collapse as a top risk by 2150. A 2025 Medium article explores AI as blind architects of collapse, engineering post-labor societies that reset humanity. And a BBC World Service video from August 2025 discusses a paper predicting AI goes rogue by 2027, leading to extinction within a decade. In this framework, hidden quantum tech could simulate interventions, when to deploy comets like 3I divided by Atlas to nudge failing civilizations back towards stability. Discovered July 1st, 2025, its CO, 2, 8-to-1 over water could theoretically aid Mars's atmospheric restoration, linking to Sapphire Canyon's biosignatures from September 10th. If these supercomputers exist, perhaps in Utah's deserts or under Sahara sands, they might use quantum entanglement to process vast data sets, predicting when a society like ours, facing climate and AI risks, needs a cosmic boost. A 2025 Live Science article on supercomputers simulating the universe underscores this power, modeling dark matter and plasma on scales we can't fathom. A HPC Choir piece from 2022 shows supercomputers delving into underwater mysteries, hinting at their versatility for hidden predictions. Speculate. What if quantum archaeology reconstructs collapsed civilizations? A 2023 Substack post meditates on resurrecting the dead via tech, tying to predicting and preventing downfall. A 2019 Turing Church article calls it a humanitarian project to recreate the past, including people and events. For 3, I divided by Atlas. Perhaps it's a probe from such a system. Its green glow dicarbon or cyanide a signal for quantum decoding. No evidence, but the flyby during solar conjunction, blinding Earth telescopes, feels orchestrated for discrete operation. These mysteries aren't baseless. A 2022 Future Timeline forum discusses technological resurrection via quantum archaeology. A 2011 Metacanon blog envisions posthumans using it to trace effects to causes. Hidden in deserts, where preservation is ideal, minimal water, stable temps, these systems could monitor global data, predicting collapse as in a 2024 YouTube video on MIT's 2040 forecast. Link to 3, I divided by Atlas. If predicting collapse, intervention might involve redirecting comets for resource delivery. Its timing with biosignatures suggests a nudge toward Mars habitability, perhaps for humanity's backup. A 2025 TechExplore article on supercomputers simulating droplet shocks for Europe's fastest machine shows predictive power. A 2019 Live Science piece on a supercomputer spanning continents hints at global hidden networks. The allure, if real, these techs could avert doom, as in a 2025 Reddit post on AI collapse by 2027. Wikipedia on AI existential risks debates AGI's role in extinction. For 3, I divided by Atlas. The Mars orbiters Trace Gas and Express might detect anomalies during the flyby, like targeted outgassing, tipping toward engineered over-evolved. Quantum mysteries and hidden tech blur reality and speculation, leaving us to ponder. Is 3, I divided by Atlas, a random wanderer or a calculated intervention? As October approaches, the deserts might hold keys, or the stars might laugh at our guesses. The truth simmers beneath the surface, inviting us to dig deeper into the unknown. What if the enigmatic 3I divided by Atlas isn't a harbinger from distant aliens, but a remnant engineered by our own ancestors, humans from a forgotten era who rose to technological heights, only to crumble and leave behind automated legacies that continue to whisper through the cosmos? This is the essence of the earlier cycle hypothesis, a provocative idea that reframes our interstellar visitor as evidence of humanity's recurring rise and fall. Discovered on July 1, 2025, with its carbon dioxide-heavy coma and green glow hinting at sophisticated chemistry, 3, I divided by Atlas could be the product of a long-lost civilization that mastered interstellar manipulation, deploying systems to restore worlds like Mars in anticipation of future rebirths. As Myth 1, I'm delving into this theory, where the lines between myth and science blur, and the comet's October 3rd flyby becomes a potential echo of our hidden heritage, tying into the Sapphire Canyon biosignatures that suggest life once flourished on the Red Planet. The hypothesis draws from the Silurian hypothesis, a thought experiment proposed by astrobiologists Gavin Schmidt and Adam Frank in 2018, which questions whether modern science could detect traces of an advanced civilization that existed on Earth millions of years ago. Named after the reptilian race from Doctor Who, it posits that industrial societies could have risen and vanished long before humans, leaving scant evidence due to geological processes like plate tectonics and erosion that erase footprints over deep time. A 2018 Scientific American article explores this, asking if we could spot signs of a pre-human industrial era in sediments or isotopic anomalies. Extending this to humans, the earlier cycle theory suggests our species has undergone multiple booms and busts, with advanced phases predating known history by tens of thousands or even millions of years. A 2025 SSRN paper on the cyclic humanity theory argues that history isn't linear, but punctuated by recurring cycles of advancement and collapse, driven by environmental shifts, resource depletion, or self-inflicted catastrophes. Evidence? Anomalies like the Göbekli Tepe site in Turkey, dated to 12,000 years ago, with intricate carvings suggesting sophisticated knowledge far beyond hunter-gatherer norms, or the submerged ruins off India's coast hinting at lost coastal civilizations swallowed by rising seas after the last ice age. Imagine a humanity that achieved spacefaring status in a previous cycle, perhaps during a warm interglacial period 20,000 years ago, developing tech to manipulate comets for planetary engineering. They might have foreseen collapse due to climate upheaval, pandemics, or wars, and programmed automated systems to persist, launching interstellar probes or redirecting comets like 3i divided by Atlas to seed or restore worlds for future iterations of our species. A 2018 Atlantic article ponders if short-lived industrial civilizations could leave detectable traces, suggesting plastic microplastics or nuclear isotopes as markers. In this view, 3i divided by Atlas's hyperbolic orbit and CO2 dominance aren't random. They're engineered for Mars's revival, timed to coincide with our rediscovery of potential biosignatures in Jezero Crater's mudstones, as announced by NASA on September 10, 2025. The comet's green glow, possibly from dicarbon or cyanide as per Hubble's September 16 data, could be a signature of ancient bioengineering, precursors to life embedded in its nucleus. Supporting evidence lurks in geological and archaeological oddities. A 2019 Discovery article on the Silurian hypothesis speculates an advanced civilization could have ruled Earth millions of years ago, leaving no fossils but isotopic anomalies in rocks. Closer to home, a 2015 Reddit thread discusses the antediluvian era, pre-flood civilizations with advanced tech, drawing from myths like Atlantis. Recent AI-driven discoveries bolster this. In 2025, researchers using artificial intelligence uncovered a 5,000-year-old civilization beneath Saudi Arabia's sand dunes, with hidden structures and tools suggesting early advancements. A similar find in Dubai's desert, reported in 2025 by Pi Lessons, revealed a 5,000-year-old site using AI and radar, reshaping our view of ancient ingenuity. These desert sites, preserved by arid conditions, hint at hidden tech, perhaps remnants of earlier cycles, where civilizations buried quantum-like systems to survive resets. A 2024 Brighter Side News article on AI uncovering Arabian desert secrets shows radar penetrating sands to reveal roads and settlements, suggesting lost knowledge. Quantum archaeology amplifies this, proposing tech to resurrect past civilizations by reconstructing quantum states. A 2018 Newsweek piece describes it as 3D bioprinting the dead back to life within 50 years. A 2023 Aporia Substack explores bringing back the dead through simulation. A 2011 Metacanon blog envisions posthumans tracing effects to causes via quantum archaeology. If earlier humans mastered this, they could have encoded resurrection protocols in automated systems, launching comets like 3i divided by Atlas to prepare Mars as a refuge. Its flyby during solar conjunction hiding it from Earth might be programmed stealth, allowing discreet delivery of CO2 and organics to revive a planet for resettled survivors. Critics dismiss this as pseudoscience, noting no concrete evidence for pre-human industrial eras. The 2021 Reddit discussion questions resurrection feasibility, arguing it creates duplicates, not continuity. Geological records show no widespread anomalies like plastic layers from ancient tech. Yet, a 2025 YouTube video on the Silurian hypothesis speculates advanced life millions of years ago, leaving traces we overlook. A 2025 Facebook post on the Silurian hypothesis notes, Earth's timeline allows for vanished civilizations. Desert discoveries add fuel. A 2019 Science Channel video suggests arsenic wiped out an Atacama desert civilization, hinting at hidden cycles. A 2025 YouTube on ancient desert technology questions, if climate change buried advanced societies. The theory's appeal lies in its anthropocentrism. No aliens needed, we're the architects of our fate, cycling through hubris and renewal. If earlier humans deployed automated comets, 3i divided by Atlas's timing with biosignatures suggests activation when we're ready, perhaps detecting our space probes. A 2025 BU ISOC page addresses cycles ending with the Ice Age, urging interdisciplinary study. Evidence like 10 ancient technologies still mysterious today, from a 2024 Ancient Origins article, includes Baghdad batteries and Antikythera mechanisms, hinting at lost knowledge. A 2025 YouTube on ancient clues suggests we're not Earth's first great civilization. As the Mars orbiters gear up for the flyby, per ESA's plans, they might detect anomalies targeted outgassing or chemical signatures that tip toward engineered origins. If quantum archaeology is real, as a 2015 transhumanity.net article claims, resurrecting the dead via quantum maps, earlier cycles could have preserved themselves digitally, commanding comets from hidden bases. A 2019 Turing Church article calls it a humanitarian project to recreate the past. A 2025 Quora explanation defines it as resurrecting the dead anticipating tech in 20 to 40 years. A 2022 Future Timeline Forum discusses technological resurrection via quantum archaeology. This hypothesis isn't proven, but it captivates because it makes us the stars of the cosmic drama. If 3I divided by Atlas is from an earlier US, its secrets could unlock our future, revealing how to break the cycle. As October approaches, the comet's path invites us to question, are we rediscovering our legacy, or just chasing shadows? The answers might lie in the data, a tantalizing glimpse into a history we never knew we had. As we ponder this, I'm curious, where are you joining us from? And what's the hour on your clock? Drop a comment with your location and time, whether you're watching under a starry night or in the glow of morning. Your presence in this moment weaves us into the same cosmic story, one we're all writing together. In the quiet expanse of our solar system, where a lone comet like 3I divided by Atlas traces its hyperbolic path toward Mars, humanity faces a profound test, not of technology or survival, but of our very essence. This test pits transcendence against safety, a choice that echoes through our evolutionary history and cosmic aspirations. Transcendence calls us to embrace the unknown, to stretch beyond our limits in pursuit of deeper truths, while safety urges caution, a retreat into familiar certainties that shield us from the discomfort of ambiguity. As Mr. One from Epoch Science, I'm inviting you to explore this duality, where the comet's arrival on July 1, 2025, and its enigmatic chemistry become a mirror reflecting our collective soul. With the Flyby looming on October 3rd, and NASA's Sapphire Canyon biosignatures stirring whispers of ancient Martian life, we must ask, will we rise to transcendence, fueled by curiosity and rigor, or cling to safety, wrapping ourselves in easy explanations that stifle growth? Transcendence, in its purest form, is an ego-dissolving encounter with something greater than ourselves, a concept that has evolved alongside human consciousness. It's the drive that propelled our ancestors from cave dwellings to charting the stars, a quest for meaning that transforms suffering into awakening, and the mundane into the profound. In the face of 3I divided by Atlas, transcendence means confronting its anomalies, the 8-to-1 carbon dioxide to water ratio, the green glow from dicarbon or cyanide with open-minded inquiry. It demands we fund missions like the Mars sample return, delayed but vital for analysing those leopard spot minerals in Jezero Crater's mudstone, which could confirm ancient microbial life through isotopic signatures and preserve structures. Transcendence pushes us to collaborate internationally, as with the European Space Agency's orbiters preparing to scan the comet during solar conjunction, their spectrometers hunting for organic traces that might link interstellar chemistry to planetary biology. This path isn't easy. It requires tolerating uncertainty, as the comet's flyby might reveal nothing extraordinary, or it could unveil patterns that challenge our understanding of cosmic evolution. Safety, on the other hand, is the instinctual pull toward preservation, an evolutionary safeguard that has kept humanity alive through ice ages and pandemics. It's the voice that whispers to avoid risks, to seek comfort in narratives that resolve mysteries without demanding change. In our cosmic test, safety manifests as rushing to label 3I divided by Atlas, an alien artifact, or dismissing its timing with the Biosignature announcement as mere coincidence. Without delving into the data, it tempts us with packaged solutions, social media threads, claiming government cover-ups or ancient astronaut theories that require no effort, no learning, just belief. Yet, this safety comes at a cost. It blinds us to growth. Consider how transcendence has historically driven progress. From the Enlightenment's embrace of reason over superstition to the space race's leap into the unknown, it's the choice to transcend that has expanded our horizons. Safety, while protective, can stagnate us, as seen in societies that shunned exploration for fear of the unfamiliar. This test isn't abstract, it's unfolding now. As 3I divided by Atlas approaches perihelion on October 29th or 30th, 2025, its outgassing intensifying under solar heat. The James Webb Space Telescope's recent spectra, updated September 15th, show evolving ratios, with carbon monoxide spikes suggesting deeper layers awakening. Transcendence would have us analyze this rigorously, perhaps through AI models simulating cometary behavior to predict interactions with Mars's atmosphere. Safety might lead us to sensationalize, amplifying viral claims on X that the green glow is a signal, ignoring the natural fluorescence explained in cometary studies. The duality mirrors broader human struggles. In AI development, where transcendence seeks godlike intelligence, while safety warns of extinction risks. Philosopher Nick Bostrom's work on existential threats highlights this, pondering if advanced civilizations transcend to energy beings or perish in silence, explaining the Fermi paradox. Our response to 3I divided by Atlas tests whether we'll choose transcendence's bold inquiry or safety's comforting stasis. Transcendence invites us to invest in planetary defense, like the Atlas network that spotted the comet, ensuring we detect future visitors early. It encourages educational outreach, teaching the next generation to distinguish peer-reviewed data from speculation, fostering a society resilient to cosmic unknowns. Safety, conversely, might erode support for space funding, as budget cuts delay Mars sample return, leaving biosignatures like those in Sapphire Canyon unverified. Yet, Transcendence isn't reckless, it's measured, as in the DART mission's 2022 success, deflecting an asteroid to prove we can act against threats. Curiosity thrives in this tension. What if Transcendence leads us to discover that 3I divided by Atlas's chemistry, carbonyl sulfide traces, detected by Spherex on September 12, mirrors prebiotic conditions on early Mars? A transcendent approach would model this, using stats models to correlate with Jezero's redox reactions, potentially revealing Panspermia's role. Safety might dismiss it, missing the chance to redefine life's origins. The human search for transcendence, from gods to AI, is eternal, a fundamental drive that evolves with us. In cosmic events like this comet, it manifests as choosing exploration over fear, echoing how naturalism debates transcendence in science, where reason grapples with the beyond. Humanity's test extends to ethics. Transcendence demands we confront our loneliness in the universe, perhaps finding in 3I divided by Atlas evidence of life's ubiquity, while safety clings to anthropocentrism. Transcendence, as evolution's endgame, transforming into energy beings, suggests advanced life transcends physicality, leaving silence behind. For us, facing 3I divided by Atlas, transcendence means embracing cultural evolution in a cosmic context, as NASA's 2010 book, Cosmos and Culture explores, where societies adapt to universal scales. Safety might reject this, fearing the implications for our fragility. As the Flyby nears, the trace gas orbiter's data could tip the balance. A transcendent response analyzes it deeply, perhaps revealing interstellar diversity. Safety skims for confirmation bias. Transcendence fosters unity, like global cooperation on the comet study. Safety breeds division through conspiracies. The test is ongoing, with 3I divided by Atlas as catalyst. Will we transcend toward a future of wonder, or seek safety in shadows? Our choice shapes not just this moment, but humanity's trajectory among the stars. Stories have always been humanity's silent architects, weaving the threads of our collective imagination into the fabric of reality, guiding us toward futures we first dreamed in tales around flickering fires. From ancient epics that inspired empires to modern sci-fi that propelled us to the moon, narratives don't just reflect our world, they sculpt it. Consider how Jules Verne's From the Earth to the Moon in 1865 sparked visions of space travel, influencing early rocketeers like Robert Goddard, whose liquid-fueled rockets laid the groundwork for NASA's Apollo program. Or how Arthur C. Clarke's geostationary satellites in his 1945 story became the blueprint for today's communication networks. These aren't coincidences. They're proof of narrative power, where fictional blueprints become tangible innovations, shaping technological leaps and societal shifts. In the realm of space exploration, stories have been rocket fuel for progress. The Cold War space race wasn't just about engineering, it was a battle of narratives. America's tale of freedom and innovation versus the Soviet Union's story of collective triumph. Media amplified this, with Life magazine's coverage of the Mercury 7 astronauts turning them into national heroes, boosting public support and funding for NASA. Science fiction played a pivotal role too. A 2023 Royal Institution blog highlights how H.G. Wells's The War of the Worlds and Star Trek's utopian vision inspired real advancements, from radar technology to flip phones modelled after communicators. Even today, narratives drive exploration. Elon Musk's Mars colonization story, echoed in books like The Martian, rallies investors and engineers, turning sci-fi into SpaceX's reusable rockets. But narratives can also mislead. The space opera trope of endless frontiers ignores real challenges like radiation and resource scarcity, potentially skewing public expectations and policy. Psychologically, stories are potent elixirs that reshape behavior and societies. Narrative psychology, emerging in the 1980s, views our lives as stories we construct, influencing memory, identity, and actions. A 2011 APA Monitor article explains how these tales hold sway over our identities, turning personal anecdotes into self-fulfilling prophecies. In social contexts, narratives foster empathy and drive change. A 2021 PMC study shows how storytelling boosts empathy in social problem-solving, personalizing issues, and motivating action. They can also manipulate. Propaganda narratives have toppled regimes, while positive ones, like Martin Luther King Jr.'s I Have a Dream, galvanize movements. In future shaping, narratives act as blueprints. A 2017 Science Direct paper on storytelling in energy policy illustrates how compelling tales can sway public opinion towards sustainable futures, overcoming resistance through emotional connection. Yet, fragmented narratives lead to mental health declines, as a 2015 PMC study links variable identity stories to worsening well-being over time. Astronomical events, like comets, have long been fodder for narratives that sway public perception. Halley's Comet in 1910 sparked global panic, with media stories claiming its tail's cyanogen gas would poison Earth, leading to sales of comet pills and suicides. A 2025 Arxiv paper details how a Puerto Rican cave inscription preserves this fear, showing media's role in amplifying hysteria. Earlier, the 1577 Great Comet was seen as a divine omen for the Reformation, with woodcuts and pamphlets shaping European views. In 1066, Halley's appearance in the Bayeux Tapestry portrayed it as a portent for the Norman conquest, influencing historical records. These stories didn't just reflect fear, they drove behaviors, from religious revivals to scientific inquiry, as Tycho Brahe's observations debunked superstitions. Today, media narratives about 3I divided by Atlas could shape our future in profound ways. Discovered July 1st, 2025, its CO, Too Rich Coma, and Green Glow have spawned tales of alien probes or terraforming tools, amplified by algorithms that prioritize sensationalism. An X-post from July 30, 2025, discusses how narratives around blockchain tech like boundless shape decentralized futures, rewarding creators who craft educational stories. Another from February 16, 2025, notes how entertainment narratives challenge norms, influencing societal change. In Crypto Trends, a January 14, 2025, post highlights AMA discussions on narratives driving Web3's evolution. These show how stories mobilize communities, funding innovations like space tech. For 3I divided by Atlas, positive narratives could boost NASA budgets, accelerating Mars missions to verify biosignatures, while fear-mongering might divert resources. Narratives also mold future societies through psychological imprinting. A 2022 Taylor and Francis study on emotional shifts in stories shows how narratives evoke feelings that alter attitudes and behaviors. In climate change, compelling stories personalize crises, spurring action, as a 2017 Science Direct paper details. For space, narratives like The Overview Effect, astronauts' profound shift from viewing Earth inspire environmental stewardship. An X-post from May 29, 2025, discusses how filmmakers' panels at Sloan Summit explore humanity's future through narratives. Another from April 23, 2025, notes a shift to narrative battles for minds, not resources. These highlight stories' role in fostering empathy and innovation. Yet, narratives can distort. A 2023 Frontiers study links coherent narratives to well-being, but fragmented ones to distress. In astronomical events, media hype around Halley's in 1910 led to panic, as a 2023 Nautilus article recounts. For 3I divided by Atlas, balanced stories could inspire youth towards STEM, shaping a future of exploration. Sensational ones might breed skepticism, hindering progress. As the comet's data arrives post-conjunction, our narratives will decide its legacy, driving policy towards sustainable spacefaring or retreating into isolation. Stories are tools. Wielded wisely, they build bridges to tomorrow. Mishandled, they erect barriers. In this power lies our future, a canvas waiting for the tales we choose to tell. Peering beyond the horizon of our current understanding, the arrival of 3I divided by Atlas and the tantalizing biosignatures from Mars beckon us toward futures we can scarcely imagine. As Mr. One from Epoch Science, I'm compelled to explore these vistas, where a single comet's passage on October 3rd, 2025, could cascade into transformations that redefine humanity's role in the cosmos. What if this interstellar wanderer, with its carbon dioxide-laden coma and enigmatic green glow, isn't just a fleeting visitor but a harbinger of breakthroughs that propel us into an era of interstellar exploration, ethical reckonings, and perhaps even contact with life's echoes across the void? The implications stretch far, from reshaping our search for extraterrestrial intelligence to accelerating human settlement on other worlds, all while forcing us to confront the profound questions of who we are and where we're headed. First, consider the ripple effects if the Sapphire Canyon sample's leopard spot patterns, those subtle hints of ancient microbial activity revealed by NASA on September 10th, 2025, prove to be genuine biosignatures. This wouldn't just be a scientific footnote, it could fundamentally alter our worldview, confirming that life arose not once, but at least twice in our solar system alone. The discovery would ignite a surge in astrobiology funding, drawing billions into missions designed to hunt for life on icy moons like Europa or Enceladus, where subsurface oceans might harbour active ecosystems. Imagine the philosophical shift. Humanity, long pondering its solitude, would grapple with the reality of a living universe, sparking debates on the ethics of exploration. Would we quarantine Martian samples to prevent backward contamination, or risk bringing them home to unlock secrets that could revolutionize medicine through alien biochemistry? This could lead to new fields like xenobiology, studying non-Earth life forms, potentially yielding antibiotics or enzymes resilient to extreme conditions, transforming industries from pharmaceuticals to agriculture. The Mars Sample Return Mission, a collaborative effort between NASA and the European Space Agency, stands as the linchpin for these revelations. Currently in planning, with the sample retrieval lander expected to touch down near Jezero Crater in the early 2030s, it aims to ferry Perseverance's cached samples back to Earth for detailed analysis. This isn't mere rock collection, it's a quest to decode Mars's geologic and climatic history, potentially confirming habitability over 5 billion years ago. If biosignatures are verified, the implications for future human missions escalate. Colonists could exploit subsurface water or ancient microbial remnants for life support, turning Mars from a hostile outpost into a second home. But ethical dilemmas arise. Should we alter a world that once hosted life, risking the erasure of its biological heritage? This could spark international treaties on planetary protection, evolving from current protocols to safeguard potential alien ecosystems. Moreover, discovering past life on Mars would amplify the search for current habitats, perhaps beneath the polar ice caps, where radiation-shielded niches might sustain dormant microbes, offering lessons in resilience for Earth's own biodiversity crises. Turning to 3I divided by Atlas itself, the third confirmed interstellar object after Oumuamua in 2017 and Borisov in 2019. Its study could unlock technological windfalls that propel us beyond our solar system. These wanderers, hurtling through at speeds up to 37 miles per second, carry pristine materials from other stars, offering snapshots of distant planetary formation. Future missions, like the European Space Agency's Comet Interceptor, launching in 2029, are designed to loiter at the Sun-Earth L 2-point, ready to chase such transients for close-up analysis. By intercepting them, we could harvest exotic ices or organics, inspiring advancements in materials science, perhaps radiation-resistant coatings for deep space probes or novel propellants derived from their volatile compositions. A 2025 study from the Southwest Research Institute suggests such pursuits are feasible with current rockets, potentially leading to affordable rendezvous missions that sample interstellar chemistry without the need for faster-than-light dreams. The fusion of these discoveries, biosignatures, and interstellar insights could accelerate humanity's leap to multiplanetary status. If Mars once harbored life, as implied by the Vivianite and Greigite in Sapphire Canyon, future explorers might biomine for resources, engineering microbes to produce oxygen or fuel from local regolith. This bioengineering could extend to terraforming, where comets like 3I divided by Atlas inspire methods to bombard Mars with volatiles, gradually building a breathable atmosphere over centuries. Ethical frontiers emerge. Who owns a revived Mars? Would we preserve biosignature sites as cosmic heritage parks, or exploit them for survival? These questions could redefine international law, evolving from the Outer Space Treaty of 1967 to include biopreservation clauses. Moreover, confirming life on Mars would invigorate the search for exoplanets, with telescopes like the James Webb already spotting potential biosignatures in distant atmospheres, potentially leading to a galactic census of habitable worlds by the 2040s. Economically, the implications are vast. Studying interstellar objects could yield breakthroughs in propulsion, like harnessing outgassing for sails that propel probes at fractions of light speed, shortening trips to Alpha Centauri from millennia to decades. A 2025 proposal for missions to chase such comets emphasizes using existing tech for intercepts, potentially spawning a new industry in space mining, where volatiles from these visitors fuel habitats or starships. Biosignature confirmation might boost biotech, with Martian-inspired enzymes revolutionizing medicine, creating resilient crops for Earth's changing climate, or therapies against radiation-induced diseases. Socially, it could unite us. Discovering we're not alone, even in microbial form, might foster global cooperation, turning rivalries into alliances for cosmic defense against asteroids or shared exploration ventures. Yet, darker horizons loom. If biosignatures prove microbial life extinct on Mars, it warns of planetary fragility, urging us to combat climate change lest Earth follow suit. Interstellar studies might reveal threats. What if these objects carry invasive organics, contaminating worlds? This could spark debates on cosmic quarantine, evolving planetary protection into interstellar ethics. Philosophically, it challenges our identity. If life is common, are we special, or just another fleeting spark? This could inspire spiritual awakenings or existential crises, reshaping religions and philosophies around a living universe. As data from the Trace Gas Orbiter flows in post-Flyby, the future branches, transcendence in discovery, or caution in interpretation. Beyond the horizon lies a tapestry of possibilities: human footsteps on Mars by the 2030s, interstellar probes by mid-century, perhaps even messages from other cycles of life. The comet and the rock invite us to dream boldly, curious about the paths we'll forge in the stars. As we stand on the precipice of October 3rd, 2025, with the interstellar Comet 3, divided by Atlas, poised to sweep past Mars, we're not just observers of a cosmic event, we're participants in a pivotal moment that could redefine our place in the universe. The Sapphire Canyon rock, unveiled by NASA on September 10th, whispers of ancient Martian life with its leopard spot patterns, while 3, divided by Atlas, carries a chemical payload that seems almost too perfect for reviving a barren world. As Mr. 1 from Epic Science, I'm not here to simply recount these wonders. I'm calling you to action, urging you to join a journey of curiosity and courage that could shape humanity's future among the stars. This is our chance to choose wonder over complacency, to fuel exploration with questions rather than settle for easy answers. Let's seize this moment, reflect on what it means, and commit to a path that keeps us reaching for the unknown, all while the cosmos watches in silent anticipation. This call to action begins with engagement yours, mine, ours. The universe doesn't unfold its secrets to passive spectators. It rewards those who ask, probe, and persist. Right now, as 3 divided by Atlas races toward its Martian flyby, its carbon dioxide heavy coma 8-1 over water, as confirmed by the James Webb Space Telescope, sparks questions about whether it's a natural anomaly or a cosmic nudge toward planetary renewal. The green glow, possibly from dicarbon or cyanide, detected by Hubble on September 16th, adds to the enigma, hinting at chemistry that could seed life's precursors. Meanwhile, the Sapphire Canyon sample with its vivianite and greigite minerals suggests Mars once hosted conditions ripe for microbes. These discoveries aren't just data points. They're invitations to act, to support the science that will unravel them, to challenge the narratives that oversimplify them, and to inspire a generation to look skyward. First, let's commit to fueling the engines of discovery. The Mars Sample Return mission, now slated for the early 2030s, is our best shot at confirming whether those leopard spots are biosignatures or geological mimics. A 2025 NASA press release underscores its complexity: a sample retrieval lander, an ascent vehicle, and an Earth return orbiter, all requiring billions in funding and global cooperation. Budget cuts have delayed it, but public support can change that. Write to your representatives, share petitions on platforms like X, and amplify NASA's updates posts like the one from September 12, 2025, detailing the mission's progress. Reached only 50,000 users, dwarfed by viral conspiracy threads. Your voice can tip the scales, ensuring we bring those rocks home to labs where electron microscopes and mass spectrometers can reveal if Mars was once alive. Imagine the ripple effect. Confirmed Martian life could redirect billions toward astrobiology, launching probes to Europa's oceans or Titan's methane lakes, transforming our understanding of life's prevalence in the cosmos. Next, let's embrace critical curiosity. 3 are divided by Atlas's Flyby, cloaked by solar conjunction from late September to late October, will rely on the European Space Agency's Mars Express and Trace Gas Orbiter to capture data. Their spectrometers might detect organic spikes or dust interactions, as modelled in a 2025 Icarus paper, potentially linking the comet's chemistry to Mars's past. But the internet is awash with myths, alien probes, ancient terraforming devices that drown out science. A viral X post from September 15th, claiming 3I divided by Atlas is a signal from extraterrestrials, garnered 3 million views, while ESA's measured briefings struggle for attention. Act by seeking primary sources. Follow NASA's Science Directorate, ESA's Mars updates, or peer-reviewed journals like Nature Astronomy. Share these, not sensationalism. A 2024 study in psychological science shows how misinformation spreads when we don't verify sources. Let's counter that by amplifying truth, fostering a culture of inquiry over fear. This leads to education, our most powerful tool. The comet's 8:1 CO2 ratio, detailed in a 2025 Caltech preprint, challenges cometry models, suggesting formation in a carbon-rich stellar nursery. The green glow, per a 2023 Astronomy and Astrophysics article, aligns with dicarbon fluorescence seen in Hale-Bopp. These are teachable moments. Engage schools, host star parties, or create content explaining hyperbolic orbits or redox reactions in Sapphire Canyon's mudstone. A 2025 Edutopia article highlights how hands-on astronomy boosts STEM interest. Inspire kids to code orbital simulations or analyze spectra, turning 3I divided by Atlas into a gateway for future scientists. Universities like MIT offer open courses on astrobiology. Take one, share it, and build a community that sees the comet not as a mystery to fear, but a puzzle to solve. But action isn't just intellectual, it's ethical. If Mars hosted life, as Sapphire Canyon hints, we face a moral crossroads. Should we terraform, risking the erasure of ancient biosignatures, or preserve Mars as a cosmic archive? The 2025 Philosophy of Science paper debates biocentrism versus exploitation, urging policies to protect alien ecosystems. Act by joining these debates, comment on forums, attend virtual symposia like the 2025 Astrobiology Conference, and advocate for updated outer space treaty clauses. Your input could shape laws governing Mars colonization, ensuring we balance human expansion with respect for potential life. The comet's flyby, potentially depositing trace organics, raises questions about contamination. A 2024 Planetary Protection Report stresses preventing Earth microbes from tainting Mars. Support these protocols, fund them, discuss them, and ensure our cosmic footprint is responsible. Let's also act on inspiration. The DART mission's 2022 success, deflecting an asteroid, proves we can shape our cosmic destiny. 3I divided by Atlas, with its hyperbolic path at 37 miles per second, is beyond our reach, but future interceptors, like ESA's Comet Interceptor launching in 2029, could catch such visitors. A 2025 Southwest Research Institute proposal outlines affordable rendezvous missions. Champion these by supporting space startups or crowdfunding tech like solar sails, inspired by the comet's outgassing. These could lead to propulsion breakthroughs, cutting travel time to Proxima Centauri from millennia to decades, as a 2023 Breakthrough Initiatives paper suggests. Imagine humanity as a starfaring species by the 2050s, inspired by this moment. Closing thoughts linger on what this means for us as a species. The comet and the rock aren't just scientific curiosities, they're mirrors reflecting our potential. If we confirm Martian life, it suggests the universe teems with possibility, reducing our cosmic loneliness. A 2025 Nature Astronomy review estimates habitable exoplanets number in the billions. 3. I divided by Atlas's chemistry could inform how we search their atmospheres for biosignatures. But it also warns of fragility. Mars's lost atmosphere, detailed in a 2021 Nature Geoscience study, mirrors Earth's risks if we ignore climate change. Act by supporting sustainability renewables, carbon capture ensuring Earth doesn't follow Mars's fate. The comet's CO2, while negligible for terraforming, symbolizes what we could achieve with collective will, perhaps engineering Mars's atmosphere over centuries. We must also guard against complacency. Safety tempts us with simple answers, calling 3I divided by Atlas, a random rock or an alien ship. But curiosity demands we dig deeper. The Trace Gas Orbiter's data, expected post-conjunction in late November, might reveal organic interactions or confirm natural outgassing. Whatever it shows, let's act on it. Fund telescopes, train scientists, and foster global collaboration. The Atlas Network's transparency, sharing data within hours of discovery on July 1st, proves we can unite for truth. Let's keep it that way, resisting divisive narratives that fracture our resolve. This call isn't just for now, it's for the future. If we act, we pave the way for discoveries that could redefine us. Interstellar probes by the 2040s, Martian colonies by the 2060s, perhaps even contact with other life forms by century's end. 3I divided by Atlas and Sapphire Canyon are sparks. Our actions fan them into flames of progress or let them flicker out. Choose curiosity, choose action, and let's write a story where humanity reaches beyond the horizon, not because the universe demands it, but because we dare to dream it. If this vision excites you, hit subscribe and turn on notifications to join us for every step of this cosmic journey. And hey, share a quick note in the comments. Where are you watching, and what time is it there? Maybe you're gazing at the stars or sipping morning coffee. Either way, your story weaves you into this grand tale.